Hello and welcome to my Swift tutorial for beginners. If you want to learn Swift programming, even if you've never coded before, then you're in the right place. I'll take it step by step, and by the end of this video series, you're going to have a solid foundation in Swift programming. All right, stay tuned. My name is Chris and I'll be your guide and teacher on your Swift journey. Now before we dive in, I need to tell you about two things that are going to be critical for your success. Number one, you have to keep in mind that this is a journey, and I'll elaborate on this in a second. And number two is that you're going to have to get your hands dirty. Now these two lessons I've had to learn the hard way through my own failures. When I first started learning Swift programming, I failed, and that was because I just kept learning and learning, and as I was learning, everything made sense in my head. But when I finally got to coding, I realized that I didn't retain a lot of what I'd learned, and I don't want that to happen to you. So it's really critical that you practice, and I'll help you along with that. And the second thing is that, as with any journey worth completing, there will be ups and downs. You probably will be pretty confused in the beginning, but I guarantee you, stick with it and you'll come out the other side a Swift developer. All right, now I know you're itching to get started, but just one last thing for your success. If you ever get confused or get stuck, you can simply leave a comment below and we're going to jump in and help you out, or you can join our free Code with Chris Facebook community where the team and I hang out, as well as other iOS learners. All right, now that you have the right frame of mind, let's take a look at what your Swift journey is going to look like. In this lesson, we're going to get you set up and oriented with the tools, and we're going to dive into our first Swift topic, which are variables. In the next 5 or 6 lessons after that, you'll learn more Swift, you'll do more hands-on coding, and with each lesson you progress through, you'll be layering and building up your skills, becoming a stronger and swiftier programmer. Then from lessons 7 to 11, you'll be learning more about how Swift code is structured and organized and how it's actually used. Now, even if you just get up to this point, you'll have a pretty solid foundational understanding of how the Swift programming language works and how to use it. But we're going to take it even further. From that point on, you're going to continue learning new Swift concepts and goodies that will enable you to do more and more with this wonderful programming language. Oh, and I forgot to mention, in between these lessons, I'll sprinkle some challenges and exercises that I highly recommend you do because it's going to help you discover your hidden knowledge gaps. Okay, so with that said, let's jump right in. All right, so first things first, where do you write your Swift code? Well, ideally you want to be using a Swift code editor because that way you can compile your Swift code, execute it, and take a look at the results. Well, Apple has released a tool called Xcode just for this purpose. Now, using this tool, you can write your Swift code, build your user interfaces, and build apps across all of Apple's different platforms. And what's more, this app is completely free. The only drawback is that it's made for Mac computers and there is no PC or Windows alternative. But if you're on a PC, it's not the end of the road for you because there are other alternatives, such as browser-based solutions. You can type your Swift code directly into the browser and execute it and then take a look at the results. You're not going to be able to build apps this way, but you're still going to be able to use it as a learning tool to learn Swift programming language. I wrote an article explaining all of the different options at codewithchris.com/Xcode for Windows. Now, if you are on a Mac, all you have to do in order to get Xcode is go to the Mac App Store and then search for Xcode here, and you're going to see this listing here. Now, don't be fooled by the low ratings. This is the tool that all of the professionals use to build apps on all of the Apple platforms. It can be a little bit confusing at first when you launch it, and from time to time it is buggy. However, it is the official Apple tool, so it works and plays nicely with the rest of the Apple ecosystem, including submitting apps into the app stores. So what you're going to want to do is download and install Xcode. And you have to also make sure that you're running the latest version of Mac OS, because if you scroll all the way down here, take a look at this compatibility section. If this doesn't say works on this Mac, you can actually click it and it'll tell you which version of Mac OS it requires. You want to go up here and check your version of Mac OS on your machine. And if you have a lower version, you can just search for Mac OS in the App Store right here, and it's going to be a free upgrade for you. The only question is, does your machine support this latest version of Mac OS? Even if it doesn't, and you can't get the latest version of Xcode, I wouldn't let that stop you. Use one of the browser-based solutions because you're still going to be able to learn Swift and practice Swift even without Xcode. Alright, so after you've installed Xcode, go ahead and click on Open, and that's going to launch Xcode for you. Now you're going to get this sort of welcome dialog, and we're not going to create a brand new Xcode project. Instead, we are going to get started with a playground. And that's just a lightweight little window where we can type in our Swift code and execute it to take a look at the results. It's perfect for learning Swift. If you don't get this welcome dialog, you can always go up to the File menu, go under New, and then choose Playground. So if you have this welcome dialog, just click on Get Started with the Playground. We're always going to end up in this place where we're going to choose what type of playground we want to create. So under iOS, choose Blank Playground. And you can save it anywhere you want. Make sure you remember where you save it so you can access it. I'm just going to save it on the desktop right here. Now, before we dive in here, let's do a quick tour and let me show you all of the different elements of the playground. So obviously this big main section here is the code editor. This is where you're going to be typing in your Swift code. And there is some sample Swift code here. We're not going to worry about that just yet. I also have some line numbers, which makes it very easy for me to refer to the different lines of code. If you don't have line numbers and you want to enable them, just go to Xcode Preferences under Text Editing, and you can turn those line numbers on or off. Now you'll also notice that when you hover your mouse under the different lines, this sort of blue play icon follows you. And when you drag it down, it highlights all of those line numbers in blue. Well, when you click this run icon, it basically just runs the code up to that point. So if I drag it to line number 2 and I click this blue button, it's just going to run that first line. But if I drag it all the way to the bottom here at line 4 and I run this, it's going to run all of the code up to that point, up to line 4. And you can see here, at the top, there's a status bar, which tells you the current status of the playground. It should say ready for you, and that means it's going to be ready to accept your code and run it. There's some options up here for some different views. The one I want you to click right now is this debug area, hide or show the debug area. And this is also referred to as the console area. When we're going to be testing our Swift code, we're going to be outputting information into this debug or console area. So I want you to make sure that you have this tray enabled and that you can see the output that's going to be shown there. This right hand side here is a little preview of your lines of code. I wouldn't pay too much attention to this because from version to version of Xcode it may look a little bit different. Where I want you to focus is in this debug area down here, because that should be consistent with what you're seeing in the video. Now there's one more thing I want to draw your attention to, and it's this button down here. Now this will stop executing the playground. So if I hit stop, you can see that it enables this guy again. And you can also click this button. It's turned into a play button. When you click on this icon, it's going to execute your entire playground. If you hover your mouse here and you choose a certain line of code to run the code up till, that just gives you greater control if you want to run like a segment of your playground rather than the entire playground, which is what you would click here. Now another thing is that if you click and hold this play button, you can see that there are two options. It's set to manually run, which means that every time you want to run your playground, you're going to have to either click on this play icon or choose a line and hit this blue play icon. But if you click and hold it and change it to automatically run, every time you edit the code, it's just going to automatically execute your playground and update the results. Now sometimes this can be a little buggy. And as you can see here, it's running my playground. Sometimes this takes a long time for it to be ready again. And sometimes, when it's constantly running your playground like this, you're not going to see the updated results. It doesn't work as perfectly as we would want. So if you're having some trouble with not seeing output on your playground and seeing that this is continually running, then what you might want to do is just click stop and click and hold it and change it to manually run. And when it says ready, you're going to be able to click and run your code. All right, so now that you're a little more familiar with the playground and all of its controls and different windows, now we can actually dive into Swift code. So when you're coding, you want to have the mindset that you are giving the computer instructions on how to process data. Now take for instance a stock portfolio app. If you were building an app like that, you'd have to write code to tell the computer where to grab the stock prices and then tell the computer how to manipulate that and maybe come up with the percentage lost or percentage gained, and then you're going to have to write code to tell the computer instructions on how to display that to the user in a table format. Another example, take for instance a photo app, kind of like Instagram. You're going to have to write code to tell the computer where to grab the images, right, and how to display them to user. And if the user is taking a photo and trying to upload it to their account, you're going to have to make sure that you have code containing instructions on how to take that image data from the user's phone and then where to upload it to some sort of file server and make an entry in a database. So when you're coding, you're always writing instructions for the computer on how to process different types of data. And in the next lesson, we're going to talk more about different data types. But in this lesson, I'm going to demonstrate some simple pieces of data for you. So let's take a look at the playground right now, and we're going to ignore what's on the screen right up here, these couple lines, and I'm just going to show you some data. So here's some number data, right? That's 123, or we could have like a decimal number. That's another piece of data, 0.7, or we can have some piece of text. And text is surrounded by two quotes like that, and that's a piece of text. That's another type of data. Now the data is stored in the computer's memory, which is how the computer keeps track of where the data is and what it is. In order for us to work with it, we're going to need a way to reference that specific piece of data. And that brings us to our topic for today's lesson, which are variables. And variables are a way for us to keep track of a certain piece of data. So now let me show you how to write Swift code to create a new variable in order to keep track of a piece of data in memory. So in order to create a new variable, you type in the keyword var or var, followed by a space, and then you can type in a variable name. Now you can name your variable anything you want, but it should be descriptive for the data that that variable is going to keep track of. So for example, if I had a piece of data that was someone's first name, I might name my variable first name. And near the end of the lesson, I'll tell you some more best practices about naming variables. For now, let's write first name, and that's going to be our variable name. So just like that, we've declared a new variable called first name. Now at the same time, you can also give a piece of data for this variable to keep track of, and we do that using the equals sign. So you're going to write a space and then an equal sign, and then you're going to write another space followed by the data that you want this variable to keep track of. So since we named this variable first name, why don't we give it a piece of text containing the word Tom? So let's recap what this line of code does. So we've got a piece of text data, Tom, and we need a variable to keep track of it. So we're declaring a new variable using the var keyword, and we're calling this variable first name. And then we're using the equal sign to assign that piece of text data to this first name variable. Now let's jump back into the playground and let's try this out. So I'm going to erase this sample pieces of data that we had here. And you can see this line of code actually. This line of code which came with our playground is exactly what we just showed in our slides. Except that this time the piece of data is hello playground, and the variable name is str. So here we're going to write in the line of code that I just showed you. So you want to write var space, and our variable name is first name, followed by space, and then the equal sign, and then space, followed by our piece of text data, which is Tom. Now what we've accomplished here is that we've declared a new variable called first name, and we've assigned the piece of data Tom to it. Now, whenever we want to work with that piece of data, Tom, we can just refer to our variable first name. So now let's try working with our variable. What we're going to try to do is output Tom down here in the console area. And there's a command called print followed by 2 parentheses like this. And in the middle, you can give that command something to output into the console area below. So why don't we try typing in first name in there? And what we're going to do is you can either hit the execute button here, or you can hit this blue button right there. So let's go ahead and hit execute. And you can see here that we've successfully output that piece of data, Tom. So isn't that pretty cool? Your print command is saying that you want to print the data that is referenced by the variable first name. Now let's try working with another piece of data. Let's say var stock price equals 100. Okay, and now why don't we try printing stock price? Right, and let's go ahead and click that line, and we output 100 down there. Now, just as an aside, if you're taking a look at the preview here, and you might notice this /n. Now this \n is just a line break or a carriage return. That's what puts that output in a separate line down here in the console. Now what I want to show you is that you can actually reuse your variable. So you don't have to declare it again, and you can just write stock price. You can change the stock price, let's say 50, right? You don't have to redeclare it because you've already created that variable or declared it. So now down here, if I print out stock price and I hit the run icon, you can see that it's 50. Well, where did the 100 go? Well, it's basically you've lost track of it, because this line of code, you're saying that now the variable stock price should keep track of the piece of data 50. So go ahead and give this a try. If you're playing around, you might notice something like you cannot assign a piece of text data to stock price. Let's say, I'll just use Tom again. You can't assign Tom to the variable stock price. And this is because the variable stock price is expecting number data only. In the next lesson, when we talk about data types, I'm going to explain to you a little bit more about why this is. But for now, just know that when you declare a new variable, as in line 5 or line 8 here using the var keyword, and you assign a piece of data to it, from that point on, when you try to reassign data to that variable, it can only be of the same type. So numbers or text. So stock price can only accept number data, and first name can only accept text data. So let's go ahead and erase this line here. So now you know how to declare new variables and how to assign pieces of data to the variable. Now there's something else you can use to keep track of data, and they're kind of like variables. These are called constants. Now the only difference is that when you declare a constant, instead of using the var keyword, you use the let keyword. So let's try declaring a constant here. Instead of using var, I use let followed by space, and then I write my constant name. So this time, let's say it's last name. And then I'm going to use the equal sign, and I'm going to assign a piece of data to my constant. And I'm just gonna write Smith. Now, what's the difference between a constant and a variable? Well, as you saw up here, with a variable, you declare it once, like in line 8 here, and then later on you can reassign a different piece of data to that same variable. With a constant, you can't do that. Once you've assigned data to a constant, you can't assign anything else to it. In fact, if you try, it's going to give you an error. So let me demonstrate. If I did something like that, Xcode would immediately tell you that you can't assign something else to the constant last name, because that's how constants work. So at this point, it might seem that variables are more flexible because you can do more with them, and constants seem a little more restrictive. And that's true, but there are instances where you would want to use constants instead of variables. In fact, if you want to keep track of a piece of data and you don't intend to change that piece of data, then using a constant would be preferable. I wouldn't worry about it too much for now. As you get farther into your Swift journey, you're going to understand when to use variables versus constants. And furthermore, when you're coding an app and Xcode has detected that you haven't changed the data in your variable, it would suggest for you to change that variable into a constant. And then at that point, it's just a matter of changing the var keyword to the let keyword. But for now, I just want you to know that there are something called constants which work like variables. All right, and the last thing I want to talk to you about is best practices for naming variables and constants. Now, I mentioned before that you do want to be descriptive with your variable and constant names so that you know what kind of data they hold. But there's a balance to that because you don't want your variable and constant names to be too long because then it can also be really hard to read. And you don't want them to be so short like str or even maybe just s because then you don't know what kind of data it holds, right? So I would say 1 to 4 words is ideal. And furthermore, if you had something like 3 words, like very first name or something like that, it can still be hard to read. So a best practice is to use camel casing. And camel casing is just where you have the first word having a lowercase letter and then every subsequent word starting with a capital letter. And you can see now that it is a lot more easy to read versus all lower caps. Okay, so before moving on to the next lesson, let's do a quick recap. You learned that variables are used to keep track of information. You learned how to declare a new variable. You learned how to assign data to a variable. You learned about naming variables and camel casing. Finally, you learned about constants and how they're like variables, except that you can't reassign data to them after the first assignment. Now, I know that's a lot to absorb, but that's why I have a practice video for you where we're going to go through a couple of exercises for you to get hands-on and dirty with. I also have a set of recap notes that you can download. Now, the links to both of these resources are down below in the description below the video. All right, great job with lesson 1. I'll see you in lesson 2. Hello and welcome back to my Swift tutorial for beginners. This is lesson 2. If you missed lesson 1, then I highly recommend that you start there first. Now, back in lesson 1, you learned all about variables and constants and how they're used to keep track of the data in your app. Now, the data in your app can be as simple as text or numbers, but it can also be complex, such as photo data or maybe employee records in a company database. In Swift, there are different data types to categorize these different kinds of data, and that is today's topic. So let's dive in. So I've got a brand new playground here, and I want to show you something that I did a little preview for you in the last lesson. So here we have a variable called str, and we've assigned a piece of string data or text data into that variable. And I showed you last time that you're not able to do something like this when you reassign data to a variable. You can't change the data type. Now, data types were something that we glossed over in the previous lesson, but that's what we're going to talk about here today. So in Swift, there are different types of data. So far, you've been introduced to strings, which is essentially just text data. And I know that's a little bit of a weird name for text data, but you can think of it as a string of characters. At least that's how I thought of it when I first started. And then int is for integers. Now, these represent whole numbers, positive and negative. And then you have your decimal numbers, and you actually have 2 data types to represent your decimal numbers, where you have float and you have double. The only difference is that double is more precise, so it can actually store longer decimal numbers. And then lastly, for this slide at least, we have Boolean, or just bool, and this represents true or false data. It's perfect for data where there is only one of 2 options. So those aren't the only data types in Swift. However, they're probably the most common that you'll work with for a while. And also, when you get a little more advanced, you're going to be able to create your own data types that are more complex than the ones that I just showed you. Just as a quick example, you might create a data type called person, which includes a lot of information like your age, your hair color, your eye color, your ethnicity, your likes and dislikes, and all of that sort of stuff. That's a lot of data, but it's all related to one type, which is a person. So quick example, quick preview, but for now, let's just focus on these common, simple data types. Now what I want to do is I want to focus on the practical side of data types. So I'm going to show you in terms of declaring variables and constants, how you would specify the data type for your variable or constant. So in the last lesson, you learned that in order to declare a variable, you would use the var keyword followed by the variable name. And for constants, you would just use the let keyword. And then you would use the assignment operator, in other words, the equal sign, to assign some sort of data into that variable or constant. Well, one thing that I did leave out was an optional part of this variable or constant declaration. And that is that after your variable or constant name, you can put colon followed by the data type that you expect this variable or constant to keep track of. So in this example, we are assigning some string data to our variable. If I were to explicitly declare that my variable can only hold string data, I would put colon followed by string, which is the data type name. So now let's take a look at our playground again. Why up here in this variable declaration was there no data type specified? Well, that's because you don't really have to do it. If you don't specify the data type, what's going to happen is it's going to take on the data type of the first piece of data that you assign to it. So if my first piece of data was actually an integer, like 100, then my variable str would now be an integer data type variable. So now you can see that this line actually doesn't produce an error because I can reassign data to my variable as long as it's the same data type that it took on in the first place. Now just a quick note, why is it that if this variable is an int type of variable, why is it that I can't assign a piece of string to it? What's happening under the hood? Well, the thing is, different types of data are stored differently in memory. And so when you declare a variable str and you say that it should store integers, well, to put it in simple terms, it's just going to be set up to store integers. If you were to say that that variable would store string data, it's going to be set up a different way. Now, there is a data type which gives you more flexibility in terms of storing different kinds of data, but that's a topic for another day. And the second thing is that it actually helps you as a coder, because imagine if your variable can store any kind of data, you don't know what to expect. But the fact that you know this variable str can only store numerical data, or integers to be specific, that sets your own expectation as a coder. Sometimes having too much freedom is not a good thing, because it offers more opportunities for errors. And when we're programming and when we're coding, the greatest enemy is actually us making mistakes, either in our logic or in the way that we've coded something. So that's a little bit about why there are data types. Now let's do some quick examples of some of the data types that we've talked about. So we've got str here. So let's leave this as a string. All right, and let's do another one called a. I know I'm not following my same rules about having descriptive variables, but you know what? We could do that. Let's call it an integer, and we'll do 100. We'll do a float, and this could be like a 0.1 or 2, maybe double. And you know, I'm not, and you could do var bool, this is the data type for that, and then this can be true or false. And like I mentioned before, you don't have to explicitly specify the data types like this. It's going to take on the data type of the first piece of data that you assign to it. Now this part is a little tricky because float and double both represent decimal numbers. It's just that double is more precise. So if you remove that data type, well, what kind of data type is float and double? Or sorry, these two variables, what are they? Well, it turns out that double is the default decimal data type for Swift. So this one would actually be a double data type. That's what the system is going to treat that as. And then Boolean is just Boolean. If we remove that, it's going to see true, and it's going to make this variable a Boolean type. Okay, so before moving on to the next lesson, let's do a quick recap. In this lesson, you learned about the most common data types that you'll be working with. You also learned that you can explicitly specify the data type when you declare your variable or constant. And if you don't do that, the variable or constant is going to take on the data type of the first piece of data that you assign to it. And in the last lesson, I did forget to mention that I have a Swift cheat sheet available for you to download and reference, so you can have quick access in case you forget the syntax or maybe data types or anything else, and it's very handy to keep beside you as you're learning Swift. Hello and welcome to lesson 3 of my Swift tutorial for beginners video series. Now that you know all about variables, constants, and data types, it's time to start having some fun. In this lesson, we're going to talk about a staple construct that exists in all programming languages in some form or another. And yes, I'm talking about the if statement. Let me show you what they're all about. So the reason I'm so excited to show you how to use if statements is because starting from now, you're going to be able to write code that can make its own decisions. You're going to be able to write some app logic. So why don't we start here with a constant, and we're just going to use a letter A. We'll say A equals 10. And I'm going to print a string down here. Let me just open up the console so we can see something. And I want to say, let's say A is less than 10. Or how about A is less than, yeah, I'll do A is less than 10. Now this is going to print regardless, right? Because, well, first of all, I have to run my playground. So there we go. A is less than 10. Well, this actually isn't true, right? Because A is 10, so it's not actually less than 10. And in this case, I don't want this to show up. Well, the problem is that that line of code is there, right? So it's going to be run and it's going to show up. What we can use here is an if statement. So we can add a condition and we can say that we only want to run this print statement based on some sort of condition that we can test. So let's see how we can do this with an if statement. So it all starts with the if keyword, followed by a space and then your condition, which you're going to test. I'll show you how to write that condition in just a second. But for now, let's continue with the rest of the if statement. Then you're going to have a space, and then you're going to have a set of braces, or some people call it curly brackets. Inside those braces, you're going to have the code that is only going to be run if the condition equates to true. If that condition turns out to be false, then the code inside of your braces will not be run. So now let's jump back to the playground and see this in action. So I'm going to use the if keyword here, followed by a space, and the condition that we want to test is A less than 10, right? So we're going to do A, and this is the less than operator. It's going to check, is the left side less than the right side? So on the left side we've got A, on the right side we're going to put 10, right? Followed by a space, and then we're going to open up an opening brace, and I'm going to go under the print statement and close that brace. And I'll press tab here, so we've got our line of code inside of an opening and closing brace. And this is our condition here. So it actually doesn't matter if you want to put your brace down here or up here, just make sure there's a space in between your opening brace and your condition. Now let's try to run our code. I'm going to press this blue button here this time. And you can see that now the console is empty. So what happened here was that it checked the condition, A is less than 10, and because A is 10, it's clearly not less than 10. The condition equated to false, and so it didn't run the code inside here. Now why don't we make that condition true now? All I need to do is say, is A less than or equal to 10? In that case, this condition would be true. Right, let's press run. And then you can see it printed down here. All right, so that's really cool because now you can write code that can be run based on a condition. However, oftentimes we've got multiple choices that can be made. Like for example, do you want a Big Mac or do you want chicken McNuggets? So we're gonna do this using another feature of the if statement called an else if clause. Let me show you how that works. So right underneath the closing brace of your if statement, you can put the keyword else space if, and then you would have another condition, then followed by another set of braces. Now what's going to happen here is that it's going to check your first condition in your if branch, If that happens to be false, it's going to skip right down and it's going to check the condition in your else if branch. If that also happens to be false, then it's just going to skip again and it's not going to do anything. However, if one of those conditions were true, then it would run that branch of code. And keep in mind, it's only ever going to run one branch of code. So imagine yourself standing in the middle of crossroads. There's two paths, one on your left and one on your right. There's only one path you can go down, right? So that's kind of like how the if statement works, except that it evaluates the conditions from top to the bottom. So the first condition that is true, it's going to run that block of code, and then it's just going to ignore everything under that if statement. So let's jump back into the playground and let me show you how this works. So we can say something like, let's make a 20 now. Right, so if we run this code right here, that's not going to run because it's false. Now we're going to use else space if space, and let's say is a greater than 15. Right, then I'm going to print a is greater than 15. Right, so if you run this if statement, what would you expect to happen? It would evaluate this, right? And since that's false, it's going to skip down and it's going to check this, which happens to be true, and it's going to print that. So let's give that a run. We've got a is greater than 15 printed down here. Now let me show you something else. What if a was 5 and then we change this condition like that? So this condition test is a less than or equal to 10, and this one is a less than 15. They're both true, right? I guess I'm going to have to change this too, or else it doesn't make sense. So that both of these conditions are true, what would you expect to happen when I run my playground right here? Well, it evaluated this condition, which happened to be true, so it jumped into here, this fork of the road, right? And it executed that branch of code, and it ignores everything else, right? It doesn't check the second condition at all. So that's really something to keep in mind. So another cool feature of the if statement is that you can stack these else if clauses. If you've got more things to check, more conditions to check, you can just add them to the bottom like that. So if a is greater than 30, I'm just making stuff up at this point, but you can keep going and keep going. The only thing is that you don't want to make it too long. There is actually another kind of decision tree sort of structure that you can use, which I'll tell you in the next lesson. But in this one, just keep in mind that you can check multiple conditions, but you don't want to abuse it. Now, I want to tell you about this last feature of the if statement, which is the else clause. So the else clause is kind of like a catch-all bucket. If none of the conditions at the top evaluate to true, it's going to keep checking from the top down, right? If none of the conditions above the else branch is true, then it's just going to end up executing the code inside of the else branch. So the way you include this else branch in your if statement is you use the else keyword, and then you just open a set of braces. There's no need to specify a condition because remember, the point of the else branch is to execute some code just in case nothing above it got executed. So let's jump back to the playground and take a look. So we've got a is less than 10, a is less than 15, and a is greater than 30. Well, there's a gap right in between 15 and 30. So if I said something like, a is equal to 25, and I ran the code right here, nothing would execute because none of this is true. And let's just print something here. Print a is greater than 30. All right, so nothing gets executed right here. But if I add an else branch, right, open up a set of curly brackets or braces here, a is something else. So why don't we give that a run? And you can see that indeed it falls into this catch-all branch of code. So now I've shown you all of the basics of the if statement. However, it can get a lot more complex because your conditions inside your if and else if branches can get really complex. let's say we introduce another variable here. Let b equals 10. You can start to chain these conditions together. So for example, if I wanted to check that a was less than 10 and also that b is greater than 5, and I want both of these conditions to be true in order for that branch to be executed, I can use the double ampersand symbol, which represents that I want both of those conditions to be true in order for that branch to be executed. So let's do b is, did I say greater than 5 or less than 5? I think less than 5. And this actually would not be true, right? Because a is 25 and b is 10, so it's going to skip here. So why don't we modify this a little bit? Why don't we say a is less than 10 and b is greater than 5. So while this part is true, let me just run this and I'll show you what the output is. Right, it still falls into here. Why? Well, although this is true, this is not true, right? And when you use this double ampersand sign right here, you're basically saying that you need both of those conditions to be true in order for the whole condition to be evaluated as true. However, if you don't care and you only want one of those conditions to be true, you know, either or, then you can use the OR operator, which is actually a set of double pipes. Now, I don't know if they're called pipes, but this key is on my keyboard at least is above the return key, and you have to hold shift to get them. So double pipes will give you the OR operator. And let me run this code to show you what that looks like. So we come into here and execute this. Now this statement is a little bit misleading now. So I'm just going to call it branch 1, branch 2, branch 3, and let's say catch-all. All right, so I can run that and show you that this gets printed. Because we're using the OR operator, if either a is less than 10 or b is greater than 5, then we're good. We're going to execute that branch. And that's exactly what we get here, branch 1. Now, I'm going to blow your mind further because we can further chain these things. So what you can do is you can wrap this condition, right, in a pair of parentheses like this. And then you can say, and let's say we've got a third one. And let's say we want either b is greater than 5 or a is less than 10 and c is equal to 1. Right? And if we run that, it would come into here because this part evaluates to true and this also evaluates to true. Now we can even go further and we can start wrapping that in a pair of parentheses, and you can test as many things as you want and you can build this massive condition, but just keep in mind that the more things you put in there, the more complicated it's going to get and the harder it is for anyone to understand. I want to draw your attention to one thing though, and that is this equality operator here. When we're testing equality, we don't use the single equals operator here because remember, that's for assignment. When you do that, you're trying to assign 1 into the constant c. When you want to test for equality, you use double equal sign. And when you want to test for inequality, you can use exclamation mark equals, and that is testing that c is not equal to 1. So if I run this code right here, I would get catch-all. The reason is because although this evaluates to true, this does not evaluate to true. And because we're using the AND operator there, we need both sides of that to be true. Now if I change this to an OR and I ran it, we would get branch 1. Because even though this isn't true, this is true. So it's kind of a little bit of logic there, which is fun to do, and it takes a little bit of practice to wrap your head around. Now what I wouldn't do, highly recommend that you do not do this, is don't memorize these keywords. Don't go and try to memorize, oh, I need the if keyword, I need a condition, here are all the operators I can use. Don't do that, because I'm going to introduce more keywords to you and more syntax to you, and it's not going to be fun for you to try to memorize it, and it's not practical. I talk all about being practical, and what I want you to do instead is spend 30 minutes. Take a look at the worksheet for this lesson. Try out the if statement on yourself on a playground, and in 30 minutes of learning, you're going to learn a lot more, and it's going to sink into your head a lot more. You're going to remember it a lot more than it would if you had tried to memorize this. So I highly recommend that you do instead of trying to memorize. Remember, I have a Swift cheat sheet and worksheets for you to practice what you've learned in today's lesson. I highly recommend you go through that, because I don't want you to make the same mistake that I did when I first started. Now let's do a quick recap. You learned that you can use the if statement in order to execute code based on a condition. You also learned that you can use the else if clause to specify alternative branches of code to run based on other conditions. And finally, you have the else clause to run some code if all of the conditions above it are not met. Now, one key thing to remember is that the conditions will be checked from top down, and the first condition that is true, that's the branch of code that is going to be executed, and the rest of your if statement is going to be ignored. Hello and welcome to lesson 4 of my Swift tutorial for beginners. Now, in the previous lesson, you learned about how you can use the if statement to run code based on some conditions. Now, sometimes when you really get into coding, you might find yourself ending up with a giant if statement with so many branches that it's going to give you a headache. When you see yourself going down this path, I want you to stop and consider using a switch statement. And in this lesson, I'm going to show you exactly how to use that. So the first thing I want to mention is that there is a Swift programming language guide. And I probably should have mentioned this in lesson 1, but better late than never. I'll add the link to this guy in the description below the video. Now, this contains kind of a walkthrough of the language. Actually, it's more in depth than that. It is basically everything you'd want to know about the Swift programming language. However, it is quite a lengthy read, but if reading is your thing, then I would highly recommend that you go through it. Especially if you come from another programming language, it's going to be very useful for you to skim through it, see how the structure of the language is, the syntax. But if you are an absolute beginner to coding, if you never coded before, this is your first exposure to it, then you might get a little bit confused. However, it's still a great reference in complement to what you're learning here in the video lessons, so definitely check it out. So I just wanted to point out where we are. Now, I'm not following the exact order that they have listed out here, because I feel like the way that they have laid it out is a very slow build-up until you can actually start using the language and having fun with it and building things. And so the way that I've laid out this lesson plan for you in this video series, you can it's very practical, and you can start coding and start tinkering and having fun sooner. So I just want to show you where you would find some of the lessons that we've gone through. So in the previous lesson, we talked about if statements. That's under control flow. And there's also this little drop down here. So if you pull this guy down, you can jump to different sections. So we are at conditional statements right here. So you can see the if statement gives you a couple of examples. So it's, it's really good supplementary material to what we've covered. But in today's topic, I want to talk to you about the switch statement, which is right here. So I just want for you to take a look at the syntax here. You'll notice that there is the switch keyword here, and then there is some value to consider, and then a set of braces, and inside there's these case and these default keywords. You know what? I'm going to show you how it's used inside of a playground, and I'm going to use an example, so it's going to be a lot easier to understand. So let's go ahead and do that. So let's pop open Xcode here. Let's get started with the playground. And I am just going to switch playground, and let's save this on the desktop. Let's just minimize this guy to avoid distraction. All right, so I'm going to declare a new constant here, and let's say that this is a character. So why don't we call this A? And we are going to assign it, we'll assign it A. Or let's call it character. Let's call it CHR. Now, if I wanted to test this constant and see if it was equal to A, I could do something like this. If CHR is, remember we use double equal sign for equality, testing equality, I mean. You know, I could print the character is A. And then if I wanted to go through all of the letters of the alphabet, I could do else if, you know, you get the picture, right? It would be a giant if statement, not recommended. But this is where the switch statement would come in handy. So why don't we just quickly take a look at the syntax. So just like you saw in the language guide, you start with the switch keyword, then followed by the thing that you want to check. In our example in the playground, that was the constant named CHR. And then you open up a set of braces, and then inside the braces, you put all of the things that you want to check for. And each thing that you want to check for is preceded by the case keyword. So it would be case, whatever you want to check for first, followed by colon, and then the code that you want to execute, if that case is true, followed by the next case, and so on and so forth. And at the very bottom, you have a default case for when none of the cases match, it's going to hit the default case and run your code there. Now let's jump back to the playground and see this in action. So let's erase this if statement and instead use a switch statement. So we're going to say switch, and actually you can use autocomplete and you can just press enter like that, and it's going to come up with all of the cases for you. Or you could type it out for practice. So you can see immediately it's come up with this syntax for me, which is really handy because I can actually hit tab on my keyboard and jump through the different things that I have to fill in. Well, I guess it stops right there. Let's change the value for CHR. And the pattern that I want to check for, you know, the first case would be A, right? And the code that I want to put here would be, this is an A, right? And then default might be, this is the fallback. So let's run this code and see what happens. So as expected, it hits this case and it prints an A. Now, what if we wanted to check for something else? Let's say B, print, this is a B. And if we just change that to a B and then we run it again, you'll see that it skips this case and it comes down here and prints this instead. Now, one additional cool thing I want to show you is that you can actually combine cases. So let's say for cases B and C, I want to execute the same block of code. So I want to say this is a B or C. So I would just put a comma here and I can put the other thing that I want to check for. So if CHR is a B or a C, then this code is going to be executed. And so as expected, it jumps down here. So this is pretty much it for a switch statement. It's pretty easy to use, to be honest, and it's a lot easier to read than a giant if statement. Wouldn't you agree? Now, to get more practice using switch statements, I highly recommend that you get the worksheet. Just hop on over to the resources page for this video series to download it. All right, we're starting to really get into the exciting stuff. Hello and welcome to lesson 5 of my Swift tutorial for beginners video series. Now, in the last 2 lessons, you learned how to write code that can be executed based on some conditions. Now let me introduce you to something called loops. Loops allow you to repeat a block of code multiple times, and while this might sound a little bit boring and repetitive, it's actually quite useful. Let me show you how they work. So now I'm going to demonstrate for you the for in loop, and this is going to allow you to loop a block of code for a set number of times. Let's jump into the playground that I have prepared. Well, I haven't actually prepared anything because it's a blank playground, but let me present to you this dilemma. So if we were to print hello in the console, and let's say I wanted to print this 5 times. Now I could just write 5 lines of code like this. You know, you get the picture. But we can use a for in loop to condense this code into just a couple of lines. And let's take a look at the syntax for a for in loop. So true to its name, the keywords to use are for and in. You start with the keyword for, followed by some sort of variable name. Now you don't have to use the var keyword here, you just give it a name, and then you write in, and then you specify a range. So there's a lower range followed by 3 dots and then an upper range. And I just want to mention that it's an inclusive range. So if your range is 1 to 5, it's going to loop from 1 to 5, and that would be a total of 5 times. And then you follow that by a set of braces. Inside the braces is where you put your code, and that code is going to be looped for whatever range that you've specified. So I know that this is yet another set of keywords and another sort of syntactical structure that you have to remember, but remember what I said, don't try to memorize anything. As long as you do the exercises and worksheets after each of these lessons, and you just spend 15 minutes even just trying it out and playing around with it, you will remember the keywords to use and the structure of a for and loop. You don't have to memorize anything. So that is really the way to go. And don't forget, I do have a cheat sheet for you to download on the resources page for this video series, which you can find the link to in the description below the video. So have that cheat sheet beside you, and if you ever forget, you can just refer to it. All right, now let's jump back to our playground and let's take a look at doing this for in loop. So I'm going to just create my loop right up here. So for, and then I'm going to use the variable name counter in, right? And then I specify a lower to upper range. And I'm going to do 1 dot 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 5, right? And then I'm going to put my braces. So inside these braces, we're going to put our print hello. So let me erase 4 of them, cut that one, and then let's paste it inside there. And we're gonna run our code. Boom, so now we have hello 5 times. How easy was that? Sure enough, it's run our code from 1 to 5. Now, the question is, what is this counter for? What is this variable name for? Well, the thing is, for each iteration of the for in loop, the counter refers to that number. So in the first iteration of the loop, counter actually contains 1. In the second iteration, counter contains 2, and so on and so forth. So let's say I wanted to print out the counter. Maybe I wanted to print out numbers 1 to 5. I could print counter, and then I can run that. And then you're going to see 1, 2, 3, 4, 5 output instead. Now, one cool thing is that you see that there was this yellow warning here, and that was Xcode just telling us that, hey, if you don't need to use that variable, then you don't have to specify it. But since we started using it in this print statement, that warning's gone away. So let me tell you what that warning was all about. Why don't we go back to hello? And then that little warning is going to come back. And it's telling us that this counter was never used. Consider, and this is kind of cut off. Let me see if I can show you. Consider replacing it with an underscore or removing it. So what happens is that if you actually don't need to use that sort of counter, you can replace it with an underscore like that. And that's going to be fine. That's perfectly valid for in loop syntax. Now I want to show you one more thing that might get you tripped up when you're working with loops. Why don't we add this counter variable back, because we're going to need it. So let's say I want to display, or let's say I want to add up all the numbers from 1 all the way up to 5, and I want to get the sum of all of those numbers. You know, you might do something like this. You might declare var sum equals 0, and then remember that this counter contains these numbers for each iteration, right? So I might want to do something like this, plus equals counter. And I think this is the first time you've ever seen the plus equal operator like this. This is just an increment operator. So what we're actually saying is basically add whatever counter is, add it to sum. So if sum is 10 and counter is 5, well, sum is now going to be equal to 15. So another way to think about it is that it's equivalent to writing sum equals sum plus counter. Right, it's kind of just like a shorthand. All right, so in every iteration, we're basically adding 1 and then adding 2 and then adding 3, and we're collecting it inside this variable sum. So what I want to do now is just print sum, and now let me run it. What would you expect to happen? Let's take a look. We get 1, 2, 3, 4, and 5. Well, that's not what we expected, right? Why is that? Well, let's take a look. So in iteration number 1, we declare a variable called sum. We've set it to 0, and then we're adding 1 to 0, and then we're printing that, and so we get 1. Well, in iteration number 2, counter is now 2, and then we are declaring sum and setting it to 0, so we're essentially adding 2 to 0, which is 2, and so it prints sum, and we get 2, and so on and so forth. So the problem is that in every iteration of the loop, we are declaring sum and we're setting it to 0. So we're not really getting that addition of the counter through the iterations like we want. And if you notice, you might say, why am I able to declare sum so many times? Right? Because in the very first lesson, I told you that when you declare a variable up here like this, and like str, you don't need to redeclare it in order to assign it something else, right? So I can assign Tom to str up here, and that would be perfectly fine. However, if I try to declare str again, like this, I'm going to get an error. Invalid redeclaration of str, right? You can't do that. So why is it that I can do that here? Right? In every single iteration, we're declaring a variable called sum and setting it to 0. Well, the reason is because every iteration, it's almost like a clean slate. There's no recollection of what happened in the previous iteration. So that's why that's happening. Essentially, we're resetting sum every single iteration. What we want to do instead to get the desired effect is that we should move this declaration out here and set it to 0, and then inside each iteration, we are essentially just adding the counter to sum. And we are going to get the desired effect if we do it this way. So outside here, I'm going to print sum. So let's stop it and run it again. And so we get 15, and that's the numbers from 1 to 5 all added up. Now, as you can see, up here, we've declared sum, we've set it to 0, and then down here in the for loop, in the first iteration, counter is 1, so we're adding that to 0, and so sum now is 1, and in the second iteration, we're not resetting sum, counter is 2 this time, and we are adding 2 to 1, so we get 3, and then so on and so forth, and then the loop ends after 5 iterations, and then we print sum, and so that's why we get this single number here. So I just wanted to go through that quick example to illustrate kind of how loops behave, because I know a lot of beginners who get tripped up with something like that. All right, recap time. So use a for-in loop to execute a block of code for a set number of times. And each time your code runs is called an iteration of the loop. Now be sure to practice with the worksheet for this lesson because loops are powerful stuff. Hello and welcome to lesson 6 of my Swift tutorial for beginners video series. Now in the last lesson you learned about the for-in loop, which lets you execute a block of code for a set number of times. Well, there's another kind of loop, 2 actually, that allows you to loop your block of code indefinitely until a condition is met. These kinds of loops are awesome when you don't know how many iterations it's going to take to get the job done. Alright, so let's dive in and see how they work. So in this demo, we're going to go through 2 types of loops that are really good to use when the number of times that you need to loop for is unknown. So the first one is called the while loop, and this loop checks a condition to see if it's true, and then it's going to run your code and then check the condition again, and then run your code and check the condition again. Let's quickly take a look at the syntax for this. So you start with the while keyword, and then you have a condition, and then you have a set of braces, and then inside the braces you have the code that you want to loop. Now notice that the condition is up there at the top. Before it even executes your code, it's going to check the condition first to see if it's true, kind of like an if statement. If that condition is not true, then your code is not going to be run at all, let alone loop. Let's jump into the playground now and let's do a demo of the while loop. So I've got this guy right here, brand new playground, fresh out of the oven. So var, let's use counter is equal to 5. And then let's say that I want to, let's do the same example like we did before. We're going to print hello. And what we're going to do is say while counter is while counter is greater than 0, I'm going to print hello. Now, before I finish writing the syntax for this while loop, you can see here it's telling me you need a set of braces. But before I finish writing the syntax for this while loop, I just want you to notice one thing. So first it's going to evaluate this condition, and it's true, right? You can see that counter is equal to 5, and 5 is greater than 0. So it's true. So it's going to print hello, and then it's going to loop and check the condition again, and it's going to be true again. So it's going to loop, and it's going to keep looping infinitely until we get a crash. There's an overflow. So let me demonstrate that. I would not recommend this if you've got a slower computer, and I'm not even sure if mine's very fast. So it's just going to keep going. Maybe now Xcode has something where it's, oh, I have to run my code. Let's do that. So you can see it's going bonkers, right? So I'm going to stop that right now. It's not stopping. Okay. Yeah, it's not stopping. My computer's kind of going haywire right now. So what you want to do actually is inside this while loop, you want to write some code to actually make it so that this condition can be false. So if we print it now, sorry, if I can actually get this. Yeah, so you see, I wouldn't recommend you to do this, but we can still walk through the code. So while that's running my playground, let me just explain what happened here. So I basically created a while loop that ran on indefinitely until I added this code here. So this code decrements the counter by 1. Just like you saw the other one, which was plus equal 1, and that would actually add 1 to the counter. This one minuses 1 from the counter. So it starts at 5, right? So the first iteration would be 5 and then print hello, and then it would turn that counter into 4 because it decrement by 1. Then loop again, and 4 is greater than 0, loops, and then this line would set counter to 3, and then it'd go on and on and on until it hits 0. And then 0 is not greater than 0, so that is actually allows us to exit the loop. Now, I knew that was a pretty bad idea. So I'm going to try and stop this. Oh, there we go. So can I run this now? I think I broke it. So I am going to actually quit Xcode right now. Let's see what we can do here.
Nope.
All right, guys, we're back. So all I had to do was quit Xcode and restart Xcode and run my playground again. So let's run it here. All right, so we've got our hello 5 times, which is great. Now we can talk about our second type of loop, which is the repeat while loop. So let me show you where that is. Just scroll a little down further here. The repeat while loop. And let's take a look at the syntax for this. So here you have the repeat keyword followed by a set of braces. Inside the braces, you have the code that you want to loop. And then what's noteworthy is that behind the closing brace, you have the while keyword and then the condition. So notice how the condition is at the end of the loop instead of the while loop where the condition was at the top. So essentially what happens here is that your code statements are going to be run at least once. And then after it is run, it's going to check the condition. And if the condition is true, then it's going to repeat and loop it. So that's different from the while loop, which checks the condition first, and it might not even run even once if your condition isn't true. So let's go back to the playground now and test out the repeat while loop. So I am going to declare, let's say, a counter 2, and let's do equal 5 again. And I'm going to use the repeat keyword, and I'm going to print hello. And then here I'm going to decrement my counter, just like we have up there. And I am going to say while counter 2 is greater than 0. So hello from while loop. Let me do, hello from while loop, hello from repeat while loop. And let's do that. So what happens is that we get 5 of these printouts from the first while loop, and we get 5 of these printouts from the second while loop, right? Just like we expected. However, what if I changed counter to, let's say -5, right? And I change the counter to -5, and I run it. Well, you look at that. The while loop doesn't even run once, right? Because it checks the condition first. That's not true. It's not going to run your code. Skip. This one, it's going to print it out first, and then it's going to realize that, hey, -5 is not greater than 0, so I'm not going to repeat. I'm not going to loop. So the one that you use really depends on the situation and what you're trying to accomplish. If you're writing some logic that you know you want it to happen once and it only conditionally repeats, then you would want to use the repeat while loop. However, if you want your code to only be run when certain conditions are met, and as long as that condition is still true, then you use the while loop. All right, let's recap. You learned about the while loop and the repeat while loop that lets you execute a block of code and loop it indefinitely until a condition is met. Now the while loop checks the condition first before executing the block of code and then looping. And the repeat while loop will execute your block of code first and then check your condition to decide whether or not it should repeat for another iteration. Hello and welcome to my Swift tutorial for beginners. In this lesson, you're going to learn all about functions, what they are, and how to use them. Now, functions are a critical part of the Swift programming language, especially if you're going to be building apps with Swift. So let's get started. All right, so I've got a brand new playground here, but before we dive in to write our first function, let's define what they are. At the most basic level, a function lets you take a block of code and give it a function name. And whenever you want to execute that block of code, or basically run that code, you call that function name. So that might seem really simple, but the powerful aspect of it is that it lets you organize your code into smaller chunks of code for specific tasks. So that way, if you wanted to perform a specific task, you could run that specific function. Now, they can get pretty powerful with the ability to give the function data, to have the code take that data, work with it, and return the result back to you. But in this lesson, we are just going to take a look at the basic function. So let's take a look at how to define a function first. So it all starts with the func keyword, or F-U-N-C, followed by a space and then your function name. So you can give your function any sort of name you'd like, but you should be descriptive about what that code inside the function does, so that when you want to perform that task, you know which function to call. Following the function name, you have a pair of parentheses. Now, in the basic function, we're not going to have anything in between these parentheses. But in the next lesson, we're going to learn how to add input parameters, and in between those parentheses is where you would specify those parameters. For now, we're just going to leave it as 2 parentheses with nothing in between them. All right, and then next up, we have a pair of curly braces. Now, in between the curly braces is where you would define your code for that function. Now, any code you write in between those curly braces, that's going to get executed when you call the function by its name. Now let's go back to the playground and write a basic function. So I'm going to start on the next line here, and I'm going to use the keyword func space followed by my function name. Now for this one, I'm going to call it add 2 numbers, because that's what we're going to do inside that function. and I'm going to put 2 parentheses like that. And next up, I would put 2 curly brackets. This is where I would specify the code that I want to run whenever I call add 2 numbers. So why don't we define some constants here? Let a equals 1, let b equals 2, and I'll say let c equals a plus b. So c equals 3. And lastly, I'm going to print c. Now I'm going to run my code right here. And come on, playground. All right, so now it's run, but as you can see, there is no console output. And the reason why is because this code inside this function doesn't get executed until you call the function by its name. So the way you call it is you simply write the function name, and sometimes you can even use autocomplete like that, followed by the parentheses. And if we did define some sort of input parameter here that the function would require, when you call that function, you would also have to specify that input data. In this lesson, for this basic function, we don't have to do that. All right, so let's run this line of code, and as you can see in the console, it outputs 3 as expected. Now let's try another one. So I'm going to just get rid of that line there, so we're not calling the function, and I'll call this subtract 2 numbers. I'll say let d equals 5, let e equals 1, and let f equals d minus e. All right, and here I'm going to print f. And again, nothing is going to happen until I actually call the function, right? So let's run the project now. And as you can see, there is 4. Now, this might not be immediately obvious to you, but using functions is actually a huge time savings, because oftentimes when you write your code for your app, there are instances where you're going to have to repeat a chunk of code in different places. Having duplicate code in your project is generally a bad practice and something that you want to avoid. And so whenever you see yourself having to repeat code, writing the same thing that you've written before in another place, then think about putting that chunk of code into a function so that you can call it from multiple places. Now there's one more tricky thing about functions that I want to mention to you, and that is the concept of variable scope. The idea is that any variables and constants that you define inside of your function, they only exist and can be used within the curly brackets of that function. So for example, here in the add 2 numbers function, we have declared a, b, and c. Well, outside of my function, that would be right here, I can't, let's say, print a, right? That's gonna trigger an error, use of unresolved identifier, and that's just another way of saying that it can't find what a is. It doesn't know. The same thing for b or c. And the reason for this is because we've declared a, b, and c inside that scope of that function. So that's where it exists. And likewise, inside the subtract 2 numbers function, we have d, e, and f. I won't be able to access a, b, or c here either. If I try and print a, it still doesn't know what a is. So we're going to get a crash. If for some reason you needed your variables to be able to be accessed outside of the functions, then you would have to declare these guys outside of the function. Now that's just something to keep in mind as you're starting to work with functions. For a lot of beginners, they run into issues where they're frustrated with not being able to access these variables and constants that they've declared inside their function, and now you know why. So just to recap, you learned about what functions are and how important they are because they allow us to organize our code into executable blocks, which we can then call upon to perform specific tasks. You've learned how to define a simple function, you've learned how to call that function so that you can execute the code inside of it, and furthermore, you learned about the variable scope inside of a function. And just to remind you about that, if you declare variables or constants inside the curly brackets of your function, they are only going to be available inside that function. Now in the next lesson, we're going to build upon what you've learned here and make functions even more powerful. Hello, and welcome to my Swift tutorial for beginners series. Now in the previous lesson you learned about functions, what they are and how to call them. Well, in this lesson you're going to learn how to use them in an even more powerful way, and that is to have your functions accept data and return data back to you when you call them. Alright, stay tuned. So in the last lesson we declared this function here to add two numbers, and when you call this function it prints something down in the console. However, most of the times, or rather sometimes, we declare a function to take some input, perform a specific task, and then return the result to us. So the first part of being able to do that is to specify that your function actually returns something back to you when you call it. And let's take a look at the syntax for how this works. So here's the syntax for a function that returns some data. You'll notice that we still have the func keyword and we still have the function name followed by the parentheses, but after that you have a hyphen followed by a greater than sign, which combines itself to look like an arrow, followed by a space, and then the data type of the data that you're going to return from the function. So if, in our case, add two numbers, if we wanted to return the result to the function caller, we would probably put int where it says data type right here, because that is the type of the data that we are returning. Alright, so after the data type you have a space and then you have the curly brackets again, and you would specify your code. Now if you do specify a return value like this, inside your function you must have the return keyword. And that return keyword is used to actually end the function and return the data back to the caller. So now let's jump back to our playground and modify our function to return the data to us. Alright, so we've got our function up here. So we just add a hyphen, greater than sign, and then we specify, space, the data type that this function returns. And as I've said, we're working with ints, so I'm going to return an int. So right away you can see Xcode detects, hey, you're saying that this function returns data, but you're not using the return keyword. And so we've got this error here. So let's modify our function. Instead of printing C to the console, why don't we try returning it? So we just put return space C, just like that. Alright, so let's run our function now. Now nothing gets output into the console. Well, where did C go, right? Well, what happens is that when you call a function that returns some data, like we have in this case, you have to capture that data somehow. So remember, variables and constants are used to keep track of data, right? So all we need to do is say, let's define a constant, let's call it sum, and we are going to assign to this new constant the result or the returned data from our function, add two numbers. So let's run this and see what happens. Again, actually nothing will happen because we haven't output anything into the console. But let me write this print statement here. So we're going to print sum. And as you can see, there it is in the console. So what's happening here? Well, add two numbers, we're calling this function. It's declaring A, B, and then declaring C and adding A and B, assigning it to C, and then it's returning C. Then we're assigning that result into a new constant called sum, and finally we are printing that into the console using this print statement. Now it's not really interesting that whenever we call this function it always just returns 3, right? So wouldn't it be cool if we were able to tell the function which two numbers to add? And we can do that by using input parameters. So let's take a look at the syntax for that. So like I mentioned in the last lesson, we specify our parameters in between the rounded parentheses. Now if you take a look at the screen, you're going to see how we specify one parameter for our function. And I know that's a lot of text, but we're going to jump into the playground and I will show you an example. So we first start with the data type. Let's start from the right hand and work our way to the left. We start with the data type of the parameter, and this merely specifies, if it's an int, if it's a bool, what type of data are you asking for to be input into your function, right? And take note that there is a colon in front of that. And then in front of the colon, you have your parameter name. Now you can specify any sort of name you want. You're going to be using this parameter name inside your function if you want to access that data. And then you have your argument label. Notice that there is a space in between the argument label and parameter name. Now, what's the argument label for? Well, it's optional and it helps your function call read more like natural English. I'll show you what that means in a second. For now, why don't we jump back into the playground and take a look at how we specify this parameter. All right, so let's modify our add2numbers function up here with the parameter. And before I use descriptive labels, argument names, and parameter names, I am going to just put arg here as our argument label, and I'm going to put space, and then I'm going to call this para for our parameter. Remember, then we specify colon, and then the data type of our parameter, which is going to be int. And the reason why I'm just specifying the argument label and the parameter name as these is because I want you to see what the resulting function call looks like. So down here, you can see Xcode automatically detects that this function call is no longer correct. In order to call the add2numbers function, you're now going to have to specify that parameter. So an easy way to do that is just to delete this and then use autocomplete again. And you can see here that now the function call has this, which tells you the return type of the function. Now, if the function doesn't return any data, then you're going to see void in this column instead, kind of like this down here. But our add2numbers function does return an int, so you see int here, and then you can see the parameter that it requires right here, along with the data type. All right, so let's double click that, or just press enter on that, and you can see that the argument label is right there. And then this int here, we can put a number in there. Let's put 5. So now this is how you would call add2numbers with one parameter. And you're basically passing in 5 into the function. From inside of the function, let's say that we wanted to assign that 5 into A, we would use the parameter name. We're not using the argument label, we're using the parameter name inside the function here. So why don't we go print, and the sum should be 7, right? As you can see here. Now, what if we wanted to specify another parameter so that we can also specify what B should be inside of our function? Well, you can specify multiple parameters. You would just have to use comma in between each parameter. So let's take a look at that syntax. Now, as you can see, you have a comma, and then you have your second argument label, then you have your second parameter name, and then the data type of that second parameter. Pretty straightforward, and you could repeat this for 3, 4, 5, 6 parameters, whatever you need. All right, now let's jump back to the playground and specify another parameter for our function. So we're going to go ahead right here and hit comma, and then now I'm going to say arg2 para2, and that's going to be an int. And now I'm going to assign para2 to B, and this function call will no longer be correct. So I'm just going to erase that and retype it like that. And you can see now I have to specify 2 arguments or parameters. So I'm going to say 5 and 5. And the cool thing is that, let me just go back there for a second, is when you, let's say you're specifying the parameters, you hit 5, you can press tab to jump to the next parameter. So that's a little shortcut, a little tip for you there. All right, so let's print a sum, and we've got 10. Okay, cool. So let me show you some other cool things. I did tell you that argument labels were optional, right? So why don't we go ahead and remove the argument labels here and just have the parameter name and the data type. So incorrect argument labels. So why don't we just get rid of that, and just now when you make your function call, you have to specify still 2 parameters, right? Because we still have 2 parameters, but with the absence of the argument label, now it writes the parameter name. So let's go 5 and 5, like that. Right, so generally when you're specifying parameters into your function, you kind of want to be descriptive with them. So para and para2 really doesn't mean anything. So why don't we change that to number 1 and number 2? And remember, changing these parameter names means that we also have to change this. Number 1 and number 2. And as a result, this also changes. Oops. Okay, so we can specify 5 and 5. So that's all good so far. Now, did you notice that initially when we had the argument labels, the function call was using the argument labels, right? But now that we've removed the argument labels from this function definition, this has turned into the parameter name. So if you had a need to make this read more like natural English, then you could specify argument labels to do it like that. So for example, I could say add 2 numbers, and my first argument label could be using, and my second argument label can be end, and that would become, the function call would be something like that now, right? Add 2 numbers using 5 and 5. So it reads clearly and it's really understandable. And inside your function, when you're working with your code, you still reference those parameters with the parameter name that was specified. So you have number 1 and number 2. Now another trick that you could do, if you totally want to omit parameter names and labels from the function call, and you just want to specify 5 and 5, then what you can do is, instead of using argument labels like this, you can just put an underscore in front of your parameter name. There is a space in between that and your parameter name though. So if you specify the underscores like that, then your function call would look like this. Whoops, not that one. Numbers, there we go. Now you just 5 and 5, and that now becomes your function call. So just to recap, you learned about what return values are, you learned how to use the return keyword, you learned about what input parameters are and how to specify them, you learned about parameter names, and you learned about argument labels and how to omit them altogether. Now I know it still might be confusing in your head, and that's why I highly recommend that you use the exercises and challenges to practice more. Find all those resources in the link in the description below. Hello and welcome to my Swift tutorial series for beginners. In this lesson, you're going to be introduced to classes, which is a highly critical part of the Swift programming language. Now I'm going to warn you, it's a little bit of an abstract concept, but I'm sure you'll do fine. All right, let's get started. So in this playground here, I have several pieces of information. I've got 3 variables actually. 2 of them are strings, 1 of them is an int data type. Remember back in lesson 2 of this series, I talked to you about several common data types, and I just mentioned in a brief 1-second sentence that you can create your own data types. Well, now we've arrived at that point, and what we're going to talk about are classes. And you can think of it as a way to organize your information. Now I know we talked about functions, and that was a way to kind of group pieces of code together. Well, when you think about classes, you're more so thinking about information. So for example, in this scenario, I have a name, I have a salary, and I have a role. Well, you can see where this is going. All of these different variables or pieces of information have to do with a person or an employee or something like that. So what we can do is we can group this information together into our own new data type called employee. And in order to do that, we define a new class called employee. Let's take a look at the syntax involved. So you start with the class keyword, followed by a space, and then your class name. In this case, we would call it employee, followed by space, and then you have a pair of curly brackets. Inside your curly brackets is where you would define your class. Let's jump back to the playground and define our employee class. So you start with the class keyword, followed by space, and then employee, followed by space, and then we have our set of curly brackets. So in between those curly brackets, you would put all of the pieces of information that an employee would have. So why don't we take this information up here, I'm going to cut it, and I'm going to paste it inside of our employee class. But one thing to keep in mind is that you're not defining the information for a single employee, because remember, we are creating a new data type here called employee. So this is a general definition that you can use over and over again. Instead, you're specifying what sort of information every employee should have. So we don't fill out the specifics now. We just say that an employee data type should have a name. It should have a salary. We could start at 0 and fill it in later. And let's say for role, it should be a string type as well. And by just specifying 2 quotes with nothing in between them, it's just an empty string. So just like that, you've defined your new class, which is essentially a new data type. It's called employee, and every single employee is going to have a name, a salary, and a role. Now here's the part that is going to get really tricky, and you really have to wrap your head around that. And that is that your class that you've defined right here is kind of like a template. So now that we've defined this class, how do we use it? Well, let me show you some examples with some previous data types that we've worked with before first. So let's say we have A equals 10, and let's say we have B equals TED. That will suffice. So what's happening here with this line? Essentially, we are creating a piece of data, 10, right? It's going to be stored in memory, and then we are creating a constant called A to keep track of that data in memory. Same thing happening right here. TED is a piece of string data that we are creating in memory, and then we are creating a constant called B to keep track of that data in memory. Now the same concept applies here with our new data type. We're going to create a new employee in memory, and then we are going to create a variable or constant called C, let's say, to keep track of that employee in memory. So let me show you how to create a new employee in memory. Well, all you have to do is write the class name followed by 2 parentheses like that. And by writing this statement here, we are creating a new employee data in memory. So why don't we create a new constant and assign it to that constant. Now this employee data that you've created in memory is called an object, also known as an instance of the class. In this case, that is an instance of the employee class. So let me show you, just to drive home that this is your own custom type. When you create a constant A, that would be like that. You know, you're defining the data type of the constant, right? And this would be that. Now A and B are really simple data types, right? Integer and string. However, C is your custom type, right? It's employee, and inside contains this sort of data here. And right now, it's set to these default values which you have specified, but we can actually access that data inside of the employee, and we can set and we can also get that data. And the way we do that is using something called dot notation. So let me show you how it works. So down here, since we've created a new employee object and assigned it to C, let us change this to var actually, because we will probably be modifying it. So we write C, which points to our employee object, and we hit dot on our keyboard, and that lets us access all of that data inside of the employee class. So we have name, we have role, we have integer. So why don't we set the salary to 1,000? Well, first, yeah, let's do that. And then I can show you print c.salary, and you can see that it says 1,000 right there. I can also set the other pieces of data like that. You know, something like that. Now another cool thing about defining your own data type using a class like that is that in addition to specifying what sorts of pieces of data it should have, you can also define functions in here. Yes, you can write func space, let's say do work, right? If you forget, this is how you define a basic function here. And I'm just gonna print I'm doing work or something like that. And then let's say because they are doing work, we are going to increase his salary by 1. Okay, doing work gets you noticed by your boss, which could result in a promotion and you would get more salary. So that's at least my line of thinking right now. So let's say that that's the case. How would I execute this function? If I just try to call the function do work like this, it's not actually going to be recognized. Because this function is part of my employee class, I would actually have to call this function on an object of that class. Because I've created an employee object right here and assigned it to C, I can actually do C using dot notation now, and you can see that I can access this function. Actually, why don't we change our print statement here and insert the name. Let's say, but why would you refer to yourself in the third person? It's doing work. How about, hi, my name is, and I'm doing work. I don't think I'd hire someone like this who refers to themselves like that, but let's see what happens. Okay, all right, it's running. All right, hi, my name is Tom and I'm doing work. So that's pretty cool. Now I want to show you something else. So I'm going to define another employee. I'm going to create another employee object in memory, and I'm going to set this person's name to Sarah. And let's say Sarah is let's say manager. D.salary equals, we'll do without, oh, this is an integer. And I am going to say D.toDoWork. Now you'll notice that C and D are two separate employee objects. When I'm modifying the data for D, it doesn't affect C and vice versa. And when I call the doWork function on D, it has nothing to do with the doWork function for C. So that's a basic introduction of how to use classes. So one last thing I want to mention is that when you declare a function inside of a class, it's actually called a method of that class. And these variables that you're defining inside your class are called properties of that class. And also, I want to point one thing out is that notice I can access salary from inside my function. And that is because it's declared up here. All right, so properties and methods when they're inside classes. Now there's a lot more to classes, but I just wanted to introduce them to you in this video. I hope you can see why classes are a fundamental building block to organizing your information. Now in the next lesson, we're going to take classes even further. Hello and welcome to my Swift tutorial series for beginners. In this video, you're going to learn about inheritance, otherwise known as subclassing, which allows you to create a class which builds upon or extends from other classes which have already been defined. Now this saves us a lot of time and effort from defining classes that do similar things. All right, so stay tuned. I don't know if you've noticed, but now that we've talked about functions, having the ability to organize your code into chunks, and then classes, being able to organize and group variables and functions together in a way that makes sense, these are all different ways of organizing your code. Now, today's topic, subclassing, is another way to further organize your classes. So remember what I said about duplicated code and how it's a bad practice to have duplicate code all over your project because it makes it hard to maintain and hard to manage, hard to make changes. Now, when I introduced functions, I told you that having duplicate code all over your project is a bad practice, and it is. And functions were a way to address that. You can define a function and then you can call it from multiple places when you need to execute that piece of code. Classes are the same thing. Sometimes you might have to define two classes which are very similar. So instead of having two very similar definitions or classes, you can use subclassing and have one class extend from the other. So that's what subclassing is all about. Let's take a look at an example using the playground that we had yesterday. We had defined an employee which had a name, salary, and a role, and a method called doWork. Now remember, these are called properties of the employee class, and this is called a method of the employee class. Now, let's say that I wanted to create another custom data type called manager, right? So I would define a manager class like so, right? Now, a manager also has a name, right? So I can go ahead and define that. Managers also have salary and roles, and they also do work. So, I would just be defining the same thing, very close to it, all over again. Now, instead of doing that, what we can do is have the manager class be a subclass of the employee class. So we can define that, or we can do that by putting a colon after manager, and we can specify employee. And that is basically saying that the manager class inherits or is a subclass of the employee class. And this also means that the manager class automatically inherits all of the properties and methods of the employee class. So let me demonstrate for you. So let's say let m equals, let's use var, m equals a new manager object. So I've just created a new manager piece of data in memory and assigned it to m. I can say, you can see here, Maggie, maybe she's got a bigger salary, role of manager of IT or something like that, right? And M can do work. So, hi, my name is Maggie and I'm doing work. Now let's say as a manager, you also want to keep track of the size of the team that the manager is managing. So for the manager class, we could have another property called team size, and we can start that at 0. But now for my manager object down here, in addition to all of these properties and methods that it inherited from the employee class, in addition to that, it also has the properties that I've defined inside the manager class. So I can say the team size is 10. Now essentially, I was able to create a new class based off of an old class, right, and add additional functionality to it. Now you can also modify existing functionality. So let's say that, when a manager does work, he or she is not just doing work, he or she is managing people. So what we can do if we wanted to change the definition of do work, we can redefine it here after using this keyword override. So I'm going to override the do work method, and I am going to print I'm managing people, very important, right? And the salary increase, wow, it's going to increase by 2. All right, so now when I run this, it's not going to say, hi, my name is Maggie and I'm doing work. It's going to take this overridden function, right? Because M is a manager. So that's why we get down here, I'm managing people. But did you know that if you wanted to, instead of replacing the functionality of that inherited do work method, let's say you just wanted to increase the functionality, you wanted to add to it. So what you can do inside here, after overriding it, you can call the do work method of the employee class from here. All you have to do is write super dot, and you can access these properties, or you can call the do work method. So now when I write m.doWork, what it's actually going to do, it's going to execute the do work method definition from the employee class. And then after that, it's going to do this additional code that I've written here. So let's run our project and see what that looks like. You can see, hi, my name is Maggie and I'm doing work and I'm managing people. The reason why this keyword is called super is because the class that you're subclassing from is also known as the superclass or the parent class. So for the manager class, employee would be the superclass or the parent class. And that's why this keyword is called super. All right, so in addition to being able to redefine the methods of the superclass, I can also declare new methods. So I can say, you know, fire people. Oops. What's going on? I'm firing people. So now I can say m.firepeople. But, you know, if I, let's say, declare a new employee here just to demonstrate, using dot notation on the employee object, you can see I only have those things which have been defined in the employee class. So that's how powerful subclassing can be. It can really save you a lot of work. You're not going to have to redefine two different things that are very similar. What we've got right here is actually one level of subclassing or one level of inheritance, but it can actually go much deeper than that. For example, an employee is also a person, right? And all people have names. So I could, for example, declare another class up here which contains the name property, right? Because all people will have a name. And you know, so then inside the employee class, I wouldn't have to define that. And instead, I can go that the employee is a subclass of person, right? So you can build these hierarchies and these trees, and it's really a way of organizing your data and your information. Now, inside of your classes, you're organizing your properties and your functions. So now you can see holistically how all of these things are starting to come together: variables, functions, and classes. Okay, so this was a simplified example of subclassing, but it's essentially how it works. And it's very predominant in the Swift programming language, as you're going to see in the next lesson. As you can see, subclassing helps you save a lot of time by allowing you to define your new classes based on what already exists, and then improving upon that or customizing it a little bit without having to redefine everything all over again. Hello and welcome to my Swift tutorial for beginners. In this video, I want to introduce you to UIKit, which is an Apple framework that contains a lot of the classes we're going to need in order to construct iOS apps. All right, so let's dive in and see what's available in UIKit. So if you imagine most apps, there are common elements between all of them, such as labels, buttons, maybe text fields, images. And if we were to build each of these components from scratch every single time we built an app, it would be very time consuming and a lot of wasted effort. And so Apple has provided us a library of all of these pre-built elements that we can use in our apps, and they've called this library UIKit. That's what we're here to discuss. Now, UIKit contains a lot of user interface elements, and I know it strays a little bit away from Swift programming, which is what this series is about, but one of the very interesting things about UIKit, which is relevant to what we've been talking about, is how they use inheritance and subclassing to create all of these different UIKit classes. So I'm going to go through that with you as well. But first, let's take a look at where you can see the documentation for UIKit. So if you just type into Google Apple space UIKit and do a search, it should be the first result. When you click on that, you're going to get to the reference page or the documentation page for that. And then you scroll down and you can see all of the different things in UIKit. You can see it doesn't just contain user interface elements, but it contains other things like classes for animation, touches and gestures, drag and drop, and stuff like that. Another really handy way to explore UIKit, which I recommend even more, is just to open up Xcode. If you go under Window, you should see Developer Documentation, and that's what you want to click and bring up. On the left-hand side, under Swift, you're going to find UIKit near the top. And it's much easier to browse this like that. One of the things that they have removed is kind of a hierarchy that shows you how each of the classes are subclasses of other classes above it. And so I wanted to pull up that diagram for you to illustrate how they're using inheritance and subclassing. And so I Googled it, and I found an old image from back then that shows you how each of the elements derive from other elements. And all the way here on the right-hand side, you're going to see this UI button here. And this is your classic or standard iOS button that you would put in your view. But notice if you follow the lines that it's a subclass of UI control, which is a subclass of UI view, which is a subclass of UI responder, which is ultimately a subclass of NSObject. So it's very interesting to see. If you are curious about what any of these classes do, you can go into this documentation, which I showed you here. Let's say we go under button. Great. You can see the declaration here, class UI button, that its subclass is from UI control, just like we saw over there in that hierarchy. But if you click that UI control, it's going to bring you to that class and you can read about it. As you can see, it's the base class for controls, which are visual elements that convey a specific action in response to user interactions. Pretty cool. But down here you can see that UI control is actually a subclass of UI view. So we click on UI view and see what that does. It is basically something that you can put on the screen for the user to see. Now UI view is actually a subclass of UI responder. What's that? Click into there. It's an abstract interface for responding to and handling events, which explains why so many user interface elements are ultimately a subclass of UI responder. But UI responder itself is a subclass of NSObject. So what's that? Click on that. The root class of most Objective-C class hierarchies, and we're going to talk about that in a second, why that says Objective-C, from which subclasses inherit a basic interface to the runtime system and the ability to behave as objects. So it's basically what makes an object tick, if you will. And the reason it says Objective-C is that originally, before Swift, the language to build apps was Objective-C. So a lot of UIKit is actually still written in Objective-C, with Swift being a layer on top where you can use these classes as Swift. One of the dead giveaways is this NS prefix in front of the class name. Usually when you see that, you can expect that that is an Objective-C class. However, whether that's Objective-C or Swift, that's not what I wanted to point out to you in this lesson right here. What I wanted to show you was how Apple has created this whole UIKit library from all of this inheritance and subclassing. Right? That's really cool to see how they organized all of the different pieces there. And then B, to let you know that there is this UIKit library at your disposal with so many pre-built components that you can use to build your app. Now, once you finish this Swift programming series and you move on to learning about Xcode and building user interfaces and stuff like that, all of these classes are going to come in handy. All right, so at this point, that's all you need to know about the UIKit library. I'll see you guys in the next lesson. Hello and welcome to my Swift tutorial series for beginners. In this video, I want to talk to you about initializer methods for classes. These guys exist to make sure that when you create a new object of your class, that object is ready to go. Plus, you can customize these initializer methods to set up your object in any way that you want when you create a new object from your class. All right, so let's get started and see what that all means. So what I've got here on the screen is the playground that we created back in the classes part 2 lesson when we were talking about subclassing. Just to remind you, we have a person class, and then we have an employee class, which is a subclass of that person class. And then we have a manager class, which is a subclass of the employee class. So now that I've jogged your memory about what we have here, why don't we create a new person object? Do you remember how to do that? First of all, you use the class name followed by 2 rounded parentheses, right? Let me show you. Let's do it here. Person, 2 rounded parentheses. And just like that, we've created a new person object. Well, what you might notice is that this kind of looks like a function call, right? Remember, to call a function, you write the function name followed by 2 rounded parentheses and then any input parameters in between those parentheses. In this case, right here, person with these 2 rounded parentheses, you actually are calling a function of that class. Now, I know that might seem weird because if you scroll up to the top here, we don't have any functions declared in the person class, right? Well, there's actually a initializer function that is default to all classes that you don't have to declare. And let me show you what it looks like because you can explicitly declare it. So if we were to explicitly declare the initializer function of the person class, it would be using the keyword init, followed by 2 rounded brackets, followed by these curly brackets. And you can put any sort of initialization code in here. Let's say custom init code. Also notice that for this special initializer function, you do not need the func keyword that we normally use to declare functions. This is an initializer function. So let's say, for example, I put in here that I want the name property to be Joe, right? And now if I create a new person object, I say let my person equals new person object, what's actually happening here when I call this, it is creating a new person object, but it's using this init function here, right? And it's actually setting this, it's running this custom code. So to prove it to you, why don't we print out the name right after creating that object? So you can see here it says Joe as the name. Now the initializer function is useful for you to put any custom code you want in there to set up the object. If you don't specify an init function at all, like what we had before, then it's still there. You can still create new objects from that class. And that's actually what the purpose of the initializer function is for, right? It's to set up a new object of that class, allocate it memory, do whatever it needs to do to return that object to you ready to use. Now here's the interesting thing about initializer functions. So we can have our basic one, but we can also have different ones which accept parameters. For example, let me show you this. We can accept a parameter called name. Let's make it a string, like that. And then we can also have our basic one that we had before, like that. So we can have multiple initializer functions. Let's go back down here. Now I can create a person object with the basic initializer function, which doesn't do anything. And when I run this code, it doesn't print anything out because I haven't written anything in that init function. However, don't forget that I created another one, right, which accepts a name. So this time I can put in a name like that. If I print it, not doing anything right now. Did I? Oh, did I do it? Yeah, my bad. I didn't do anything in here. So what I wanted to do inside this initializer function was to set the name property to the name input parameter that got passed in here. Now I could write something like this, where I'm trying to set this property, right, to the name that gets passed in. But as you can see, it's a little bit ambiguous. Xcode is telling you that there's an error, but it's not recognizing that I'm trying to set this property. It thinks I'm trying to set this parameter to that parameter. So what you can do in this case to resolve this ambiguity is to use the self keyword. So you can write something like that, self.name. And when you do this, this is referring to that object's name. So this is basically referring to this property here. And now this name is from this parameter. So it's very clear what you're trying to do here. All right, so let's run this code again. And you can see that this time it prints Tom. Now let me ask you another question. Since the employee class subclasses the person class, that means that the employee class also inherits all of its functions from the person class, right? Do you think that this employee class also has these init functions? Why don't we give it a try? Go back down here, let my employee equals employee. And as you can see, the employee class does have this init function that it inherited from the person class. So I can use this with the employee class as well. So that's pretty cool. Now I want to talk about overriding init functions. Just like how we talked about right here, where the manager class overrides the do work function of the employee class, and then it calls super.doWork, which is going to execute the employee's do work function, as well as any code down here. The same thing applies for init functions. So let's say that we have in the person class, we have this init function, right? Where you pass in a name. Let's say for the employee class, I wanted to do something extra. I wanted to override init. So we're going to override the same function from the person class. We're overriding this guy right here. I also want to initialize the role. So I'm going to do self role. Let's default everyone to analyst or something like that. All right, everyone starts off at the analyst level. However, what I can do is call this person's, I'm going to call the superclasses init function and pass the name into there. So this is calling the init function of the person class. This is additional init code. All right, so now by calling this init where I pass in the name of the employee, like if I print my employee dot role, print my employee dot name. So you can see that it's set to analyst and it's set to Joe here. So what I wanted to demonstrate here was that even with init functions, you can use the override keyword and provide a custom implementation of that initializer function, and then also call the superclasses implementation as well. So I hope that was clear. If it's not, just leave a comment below and I'll be happy to clarify things for you. All right, later on we'll dive a little deeper into initializer methods, and we'll talk about how there are two different types, one called designated and one called convenience initializers. Hello and welcome to my Swift tutorial for beginners. In this video, I want to tell you all about optionals, which are probably one of the most confusing topics for beginners. If you've ever looked at Swift code and come across exclamation marks or question marks, then you've come across optionals. So let's get started and find out what they're all about. So to demonstrate what an optional is, let's first take a look at how we've been declaring our variables and constants. As you remember, whenever we declare a variable, we use var and then we use some sort of name. Let's just say A for this example. And up till this point, you've always seen me assign something into my variable declaration. Something like this. Or whether I declare, a string, I'm always assigning a piece of data into my variable declaration or constant declaration right away. Now, there will be instances when you're building apps that you may not want to assign data to your variable right away. You might just want to declare it. But if we try to do that, let's erase this assignment statement and erase the data as well and just leave it at that. You'll see that Xcode really doesn't like that. And that's because it wants to make sure that all of your variables and constants actually are keeping track of some sort of data, because that's the purpose of the variable and the constant, right? Well, using optionals, you can create a situation where you declare a variable or a constant without assigning something to it first, in which case it is empty. So how do you define emptiness? Well, there's actually a type for empty, and it's called nil. And it's simply a keyword like that, NIL, which stands for empty or nothing. Now, if we don't want to assign actual data to our variable first, we can assign it nil, like that. Right? And that means that that variable contains nothing. However, as you can see, we're still having some problems here. Remember I told you about data types for variables and how variables can only store data of a certain data type, and you can explicitly state the data type of that variable, and if you don't, then it's going to take on the data type of the first piece of data that you assign to it. So for example, for A, if I did that, then it would take the data type of my integer and it would determine that A should have the data type of int. In the case of nil, however, there is no data type for empty, and so variable A really doesn't have a data type right now, and we have to give our variable a data type. So in this case, if you're going to assign empty into your variable, that means you don't want to put any data into it yet. We have to explicitly put a data type. Now let's go ahead and put int, right? And for this one, let's put string, like that. Let's run it. As you can see, there is still a problem because the int data type doesn't include empty. In fact, none of the data types include nil as a valid value. The nil is not a valid integer, and nil is also not a valid string. So that's why we can't assign nil to an integer variable, and we can't assign nil to a string variable. Well, this is where optionals come in. By adding a question mark to the data type like this, this becomes an optional integer, which means that it could either be an integer or it could be nil. Same thing goes for this right here. The data type is now, it's not string, it's an optional string, which means that it could contain a string object or it might contain nil. So that's the gist of an optional. In order to demonstrate how to work with optionals, I'm going to use another example. So let me delete this for now, and then let me grab a piece of code that I prepared for you. Let me just run the project here and make sure that it runs. As you can see here, I have a class called Christmas Present, and this class contains a function called surprise, which returns an integer. Now this integer is going to be a random number from 1 to 10. So why don't we just use this code here. Let's use let present equals, let's create a new Christmas present object using that. Remember initializer functions, right? And then we want to activate the surprise. So, present dot surprise, and then we're going to print the output of that function. So let's run our code, and we get 5 in our console right here. So that's the surprise. Now, this data type of this constant right here, if I explicitly declare it, would be the type of my class, right? Next, why don't we make this an optional type by adding the question mark there? And then let's say that we put nil in there. You can see here that there's an error. Xcode says that the value of optional type Christmas present must be unwrapped to refer to the member. Think of member as function or property. Must be unwrapped to refer to the function surprise, right? And the reason for this is because I told you with an optional data type, this constant could contain a Christmas present object, or it could contain nil. And in this case, we do know that it contains nil. So what that means is that you have to check that optional constant or optional variable to see if it actually contains an object or if it contains nil before you access any of its functions or properties, because you can't call a function on empty, right? You can't access a property of nil. So what we have to do in this case is just double check that the constant present actually contains an object, a Christmas present object to be specific, before we call the surprise function on it. Now there are several ways of checking an optional type to see if it's nil before using it, and I'll demonstrate some of them. Let me erase this line first. So we are going to check the optional to see if an object exists, or if it contains an object. Let's say it like that. So First thing we can do is basically compare it to nil with an if statement. So if present is equal to nil, if this is true, then it contains nil. So don't do anything with it. Else, it contains an object. Right? Now the reverse of this is also true. You can check if present not equal to nil, right? Then if it's not equal to nil, then it contains an object. So why don't we use this statement here, because we want to only call the surprise function if there is an object, and we don't really need to do anything with it if it is a nil. So why don't we erase this one here, and let's use this one. So it contains an object. Now call the surprise function. Now, since I have already checked that it contains an object, I should be able to just call surprise, right? You'll notice that Xcode has helped us put this question mark here because that's what it thinks you want to do. But I'm going to erase it because I want to demonstrate something for you. See, if I try to run this, there's an error because you see, with an optional variable or an optional constant, before you can actually access the value inside that optional data type, whether that's an actual object or whether that's nil, you have to unwrap that optional. Now I know that's a weird term, but a good analogy or a good metaphor to think about an optional variable is that it's like a Christmas present or it's like a box. And you don't know what's inside of it. It could actually contain an object or it could be nil, but you're never going to know unless you unwrap it first. You open that box to see what's inside. Now right here, you might say, hey, we've already checked that it's not nil, right? So this check is kind of like taking that box and just shaking it and listening to it. You know, when you're a kid, trying to find out what's inside your present, that's what that's like. And all that does is that it tells you if there's something inside. I mean, if it's nil, you're shaking it, it's not going to sound like anything. But if there's an actual object inside and you shake it, you'll hear something. So this check right here lets you know that there is something inside. But that doesn't mean that you can access what's inside, right? Until you unwrap it. So let me show you how you can unwrap that variable and get at the object so that you can call the surprise function on it. All you have to do to unwrap this optional variable is use the exclamation mark after it. And what that does is it tears open that box and you get whatever's inside, whether that is the actual Christmas present object or whether that's nil. So because we've already checked here that it is an object, I'm going to say dot surprise. And I can print that. Right, so let's run this statement here. Actually, nothing is going to run. Do you know why? Because it's actually nil, right? So our if statement actually worked. So this if statement said, if it's not nil, right, then unwrap it and then call the surprise function on it. But since it is nil, it didn't do anything. So why don't we change this statement? Why don't we actually put a present inside the box? So now when we run it, we're going to get the random number surprise, which is 6. So now you know how optionals work. But I mentioned there are a couple of different ways of checking, right? To see if there's an object inside of your optional. So this is one way. Another way is called optional binding. And this is a little bit more advanced than that basic check there. And it's kind of another way of writing an if statement. So you say if let, let's say actual present equals present, then we will print actual present dot surprise. So let me explain this statement right here. It's still an if statement, so you're checking something. You're actually checking to see if present, this optional variable, to see if it's nil or not. If it is nil, then it's just going to pass through this if statement and not execute the stuff inside. However, if this optional variable does contain an actual object, then it's going to assign it to this constant that you're creating right here called actual present. So it's almost like two statements in one. The if statement checks to see if it's nil. If it's not nil, then you're going to assign the actual object unwrapped into actual present, this constant. And then you can, inside that if statement, you can use actual present as the actual object, because what it will do is that it's going to take the unwrapped object and assign it to actual present. Okay, so you don't have to do any unwrapping here. And then you can just call surprise. So you'll see 6 and 4. 4 was from here and 6 was from here. All right, last thing to show you about optionals is another thing called optional chaining. Now, this is what you saw a little earlier when Xcode tried to put a question mark there. So let me show you what that is. So you put a question mark next to the optional variable, and then you call your method like that. So with optional chaining, you can see we don't have any if statements or anything like that. But basically, what this does is it checks to see if this is going to be nil or if it actually is an object. If this is nil, nothing happens. You're not going to call that function. However, if there is actually an object in there, then it's going to call the next part on that object. So in this case, it's going to call the surprise function on the actual object because there is an object in that optional. So that's what's known as optional chaining. So why do we even have optionals in Swift? Well, the reason is because Swift is a type-safe language. And what this basically means is that Swift forces you, the programmer, to be very specific about the types of data that you're working with in your code. And in the long run, this actually helps you because it forces you to think about things thoroughly, such as if this variable will need to contain nil or if it's always going to have a value. And also how we're restricted to a certain data type for a variable, right? You're not going to accidentally assign another data type to that variable because it is type safe. So I just wanted to revisit some of the ways of declaring our variables and constants with optionals now, because there's one thing that I haven't shown you yet, and that's what I'm going to show you now. So in here, line 3, you see kind of the standard way where we declare a variable with the type, and then we assign data to it. And you've also seen about how you can add the question mark after the data type to turn that into an optional type, and you can assign nil into it. Well, you can also just do this. And that's absolutely fine because when you declare an optional data type like this for variable C, by default, it's going to be nil. So you don't actually have to explicitly assign nil to it. So when you're declaring optionals, I would recommend that you do it this way. There is also another type of optional that you can declare, and that is using the exclamation mark. Now I know in this lesson, I showed you that putting an exclamation mark is unwrapping that variable or constant to see what's inside the optional, right? Well, this is called an unwrapped optional. So this allows you to, D can store a string or nil, but it is already unwrapped. So you don't have to unwrap it, but it can also store nil. C can store a string or nil, but it is wrapped. So you have to unwrap it in order to see the contents, whether it's nil or the actual string. So when would you want to use this sort of optional versus this one? Well, I would say in general you would want to use this one because it provides that sort of type safety checking that Xcode has. So when you try to use C in some weird way and you're not checking against nil, Xcode is going to warn you, hey, this is an optional, so you might have to check for nil before using it. You might not be able to call this property or this method on C because it might be empty. So it provides you a all of those warnings, which makes you a better programmer and it makes your code more robust and will probably crash less. So if you use this instead, you can also store nil or values in here. So it gives you that flexibility, but it's not going to have any of that type safety checking. So Xcode is just going to assume that you know what you're doing. It's not going to warn you that it might be nil because it's already unwrapped, right? But just know that D may contain nil. So it's almost like you are driving without a seatbelt. Maybe that's a bad example, but because there are places where you might want to use this, if you know for sure that only initially it may be nil, but then after a certain point you can always be sure that there's a value, then maybe it's safe to use that. And then you can ignore all of that sort of optional binding, optional chaining, all of those checking for nil. You can save all of that code. However, if it's a variable which may contain a value and then nil, and then that value might get erased, so it's nil again and it keeps flipping back and forth, then maybe having it as this sort of optional is better, because then it forces you to remember to do that checking. So I just wanted to give one more quick example about these two kinds of optionals using our Christmas present class. So why don't we declare a new Christmas present like so. Let's say present1 is equal to, well, let's declare the type of this. So we're going to declare a new Christmas present optional like so, and we're going to assign it nil, right? And then we're going to do Christmas present 2, and we're going to use this. And remember, we don't actually have to assign it to nil, but I'm going to write it anyways, just so it's very clear to you what's inside these variables right here. So if I wanted to, let's say, do present1.surprise like that, let's remove the optional chaining. You know, we get that sort of type safety checking. It's saying that, hey, it's an optional, it might be nil. If it's nil, then you can't call surprise on it. So make sure you do some sort of checking. However, if I do present2.surprise, you can see that, let me just show you, let me type it out. You can see when I do that, there's no optional chaining there. You don't have to unwrap it at all or anything like that. It just treats it as an unwrapped optional. You can just use it as is, and you're not going to get any sort of warning. So I'm going to run this, but now you get an actual app crash. So, if this goes unchecked and you launch your app and the user is using it, then you're actually going to get an app crash, which is really bad. Whereas if you did it with this sort of optional, even as you're running it, you're going to get a warning from Xcode forcing you to fix that and address that before actually shipping your app, or even allowing you to run your code. So like all the other things we're learning about Swift, we can go deeper. There are additional things that you can learn about optionals, but this is your introduction, and I just wanted to tell you what they are and a little bit about how to use them. Practically speaking, you'll be using them most of the time like how we covered in this lesson. In the future, we'll cover more of the complex aspects of optionals. Also, you might be wondering why and when we would use optionals, but let me tell you, you will definitely come across optionals when you're building apps. And when we get to building our apps together, now you'll know what they are and how they're used because you've watched this lesson. Hello and welcome to my Swift tutorial beginner series. In this video, we're going to talk about properties, which you've been using already ever since we introduced them in our classes lesson. However, in this video, I'm going to go through some additional things that you can do with properties. All right, so let's get started. So before we start, one thing that I wanted to point out to you, just in case you didn't notice, is about property scope. So remember back when we talked about functions and talked about variable scope, and how if you declare a variable inside of a function, you're not going to be able to access and use that variable or constant outside of that function. You can only use it within the curly brackets of that function. So each function has its own variable scope. But when you declare a class, like we have, for example, here, These properties that we declare up here, they're kind of just like variables that are at the class level. So because they are declared up here at the class level, they are accessible and usable by any of the functions inside that class. So for example, here you can see our doWork function or method, sorry, if a function is inside of a class, it's called a method, remember. So in our doWork method of the employee class here, we can access the salary property because it's declared up here. And if we had more methods in this class, inside each of them we would be able to access the salary or the role. All right, so that's just one thing I wanted to get out of the way in case that wasn't clear. One cool thing that I want to talk to you about declaring these properties up here is that aside from them just being variables at the class level, there are some unique things that you can do with them. For example, let's take this manager class right here. Let's say that we wanted to create a bonus property that would basically determine how much of a year-end bonus this manager would receive as part of their compensation. So let's create a new property called bonus. However, and this is going to be an int type. However, the bonus is actually tied to how many people they manage. So you could do something like this. For example, maybe in the initializer function of the manager class, you could say that the bonus property equals, let's say, team size times 1,000. So you get an extra $1,000 for each team member that you manage. Right? So you could definitely calculate that in the initializer function of the manager and set that property. However, there is something called computed properties, and that allows you basically to make your property a calculation. So instead of having to explicitly assign 1,000 times team size to the bonus property, you could just make this bonus property a computed property. So to do that, you would declare your property and you have to specify a data type, and then you have your curly brackets. And then let me just write a comment here. This is a computed property. When it's accessed, the code in here will run. Then we'll return the value. So here we can say return team size times 1,000, and it's literally as simple as that. So the bonus property is calculated via this calculation here. The problem right now is that the team size is 0, so we need to be able to specify the team size. Why don't we set that as part of the initializer function? So we could, we don't have to override. Let's create our own one, which takes in a name, but it also takes in a team size, which will be an integer. Right, so this is our own custom initializer function for the manager class. However, because the manager class is a subclass of employee and it inherits all of the employee class's methods and properties, we have to make sure that all of those are initialized properly too. So the way we do that is we can simply call super init, which is basically calling the init function of the employee class. So we're going to pass in the name. This calls the init of the employee class. Additional init work. Here we will set self.teamSize equals team. And because the parameter is a different name from the property, we technically don't need the self. We could just do that, and it's very clear what we're trying to do. But it doesn't hurt to add the self as well. Just be consistent in your coding. All right, so now let's try to create a new manager object and then try to access this bonus property. So down here, say let m equals manager. We're gonna use our new fancy init method. Let's call her Kate, and the team size is, let's say, 11. All right, and let's print out what would her bonus be. Let's run this code. And it is 11,000. So that's pretty cool. Now there are additional things that we haven't covered in this lesson, such as getters and setters and property observers, but we'll have to do another lesson on properties later on. For now, this is a great start. Hello and welcome to my Swift tutorial series for beginners. In this video, we're going to revisit initializer methods, and I'm going to tell you about designated versus convenience initializers. So let's get started. So here I've got a person class, and all it has is one property called name, which is initialized to the string none. Remember when we talked about classes and default initializers? All classes will have a default init initializer. So that's why I can create a new person object like this. It's actually calling the default initializer. Now I told you that the purpose of the initializer method was to make sure that that object is set up and ready to go. Now in addition to allocating memory and doing all of the other things that it needs to do to create that object and return it to us, another job of the initializer method is to make sure that all the properties of that object are initialized. And let me show you what that means right now. So for example, in this person class, I have a name property. It's initialized with this piece of data, none. Now let's say I create an optional. Let's say, not salary, let's say net worth or something like that. And let's make this an optional integer. And that is also already initialized to nil, because remember I told you that by default the value is nil for optionals. Now I can also say gender, let's make this an optional string that is already unwrapped. Now this is also initialized to nil. So right now, by default, all of the properties of the person class are already initialized. So that's why I can create a person object like that without a problem. But let's say that one of the properties is not initialized. Now let me show you what that looks like. For example, for name, I can say that it's going to be a string type, but I can not assign it any value. Right? Then it's going to start to complain and say that, hey, your person class needs to have an initializer explicitly where you initialize the name property. So in this case, what we do is we do init, and then we assign a value to that property, right? Because this is not an optional, right? If it is an optional, then that's a different story. It is initialized to nil. But when you just say that it's a name property and it should contain a value, right? This is the string data type. It should contain a string value. And you're not assigning a value to it, then it falls on the initializer method to give it a value before that object gets passed back to you when you create a new person object. So I can show you, let's say let a equals new person object, and then I can print a.name. I can show you what that is. Right? It's none, because when we create this new person object, it's calling this initializer, and it's initializing this name property to none. I can also try to print net worth for you, and you'll see that it's going to be nil. Now, these initializer methods, which ensure that all of the properties are initialized, we're just calling them initializer methods, but the proper name is designated initializer. And these designated initializer methods can be guaranteed to return that object to you ready to use. All of its properties initialized, so on and so forth. Now there's another type of initializer method called a convenience initializer. So these convenience initializer methods are for you to kind of preset some of the properties of that object based on what you need, and then that convenience initializer should call a designated initializer just to make sure that all of its properties are set. So let me give you an example of what that looks like. So let's say that this is our designated initializer, right? Because it makes sure that all properties are initialized and it's ready to go. Now I can create a convenience initializer by using the convenience keyword like that. And let's say I want to create an initializer to create a rich female. So let's say that you need to pass in the gender and you need to pass in the net worth. Or this could be a rich person in general, right? Then I would, first of all, I would need to call the init, right? Call the designated initializer to ensure that the object is ready to go. Set any other properties or custom code to initialize for this scenario. So I can say, self.gender is equal to whatever gender was passed in, and self.networth is equal to, I forgot to put a type here. So let's say that's int. Right, missing self. All right, so this is creating a new person object, creating a new rich person object, let b equals person, and I can use my male. Let's change that to male. Like that, right? So this convenience initializer just gives me an easy way to create a specific type of person object initialized to some sort of whatever values that I need. But it calls the designated one because this is kind of like the steadfast anchor initializer that makes sure that all of its properties are initialized. So you can count on it as sort of like the go-to initializer. So just to recap, designated initializers are those that guarantee all of its properties are going to be initialized and that object is ready to go for you. Whereas convenience initializers are optional and they basically give you an opportunity to create an object but preset it to the values that you need, like what we did in this case. But convenience initializers must call a designated initializer as well, just to make sure that everything is set up and ready to go. So you can see that we did it here in line 16. So that's the difference between a designated versus a convenience initializer method. Hello and welcome to my Swift tutorial series for beginners. Today you're going to learn how to manage a collection of data in what's called an array. If you're working with many pieces of data, it's going to be hard to manage them all using just constants and variables. So let's take a look at how arrays can make our life easier. All right, stay tuned. So Swift has a couple of collection types that you can use to manage your data easily. And the one we're going to talk about right now is called an array. And this is a collection type that is ordered by indexes. And that means that there is a specific order to this list of values. So you can see here in this demonstration or this example, it starts at 0 and then it goes 1, 2, 3, 4, and so on and so forth. And at each position, there is a value or a piece of data. So there is a defined order, and that's really important to know. Let's jump into the playground where I can demonstrate a need and an example of how to use arrays. So right here, I've got three variables, A, B, and C, and let's say that I wanted to change these strings to my dog, my cat, and my bird. Well, I can go about it this way and say something like this. I can just add the word my with a space to A, right? So A is dog. I'm going to add my in front of it and reassign it to A. So that would be my dog. So I can repeat this with B and C, but I mean, this is only an example with 3 items. Let's say we had 100 or 200 items, then that would be very, very tedious, right? What I could do is also, I can put these values into an array. And what that looks like is it starts with a pair of square brackets, and each item in the array is separated by a comma. So I would have dog, comma, cat, comma, and then bird. So there's no comma at the end. It's only in between the actual items. So this is an array of 3 items with dog starting at index 0, cat at index 1, and bird at index 2. So just like what we saw here. We have dog, cat, and bird. That is our array. So having this array is great, but we need some sort of way to reference the items in the array. So why don't we assign this array to a constant called myArray. And in order to access these items, all I have to do is say myArray and then use my square brackets and then put in the index of the value that I want. So if I want dog, I would put in index 0. So let's print that, and we can see dog. If I wanted bird, I would put in index 2, right? Because it starts at 0. All right, so in that case, I could do something like this. My array 0 is equal to my space my array 0. Kind of mirrors this statement, right? And this shows you that you can use this sort of same syntax. And there's actually an error here. This is a really great example because I'm trying to assign something into my array at index 0, but this is a constant, so I can't modify it after it's assigned. So I actually need to do variable like that. Let's make my array a variable. All right, so this is great because it shows you that this syntax is to retrieve the item at index 0, but I can also assign things into index 0 using this assignment operator like that. Right, so the resulting value at index 0 is, you guessed it, my dog. Right, but this isn't very efficient either. I mean, I'd have to write this line 3 times or however many times for, however many pets I have. So this is where it gets really powerful because you can use loops we learned way back then in conjunction with arrays. So let me show you how that works. So for example, let's use a for loop, or a for in loop, I mean. Let's say there's a counter in 0 to 2. Right, so now I can say, well, why don't we just print it out for now? So we can print out my array, and then let's access the index. I can put in counter in there. So let's see what that looks like if I run this code. See, it'll print out my dog, cat, and bird, but actually it's because this line modified what was at index 0. So let me get rid of that line and let me print this again. So you can see dog, cat, and bird. It's merely printing out each index of that array. But already this is really powerful, right? Because we have one line of code and it's being looped 3 times, but each time it loops, it's doing something different. What if we did something like this? What if we did my array counter is equal to my, right, space plus my array counter. All right, now we're talking, because what we're doing here is each iteration of the loop, we are accessing that index and then we are adding my in front of it, and then we're reassigning it to that same index, basically changing the value, and then we're printing it out here. So if I had 200 items in my array, I would just change this to 199, right? And that's very little code compared to what we were doing up here, right? So you can start to see how powerful it is to use arrays with loops. Now, what if we didn't know the range of the array, right? Right here, I'm assuming that I know there are 3 items in here. That's why I'm doing this range, 0 to 2. Well, the array comes with some handy properties that we can use. One of them is called count, which returns how many items are in the array. It always starts at 0, so we're going to start at 0 if we want to access the first item in the array. However, we can use the count property of the array. So we can do myArray.count. But you're going to run into a problem with this. Let me show you why. So if I run this code, you're going to get my dog, my cat, my bird, and then index out of range. Whenever you see this error, index out of range, you start to think, this error message means that we're trying to access an index that doesn't exist in that array. It's out of the range of the array. Well, why is that? Because myArray.count returns the number of items in the array, right? So it returns 3. So our loop actually goes from 0 to 3 inclusive. So it's going to start at 0, it's going to do 1, and then it's going to do 2, and then it's going to do 3, and there is no 4th item in our array, right? This is 0, this is 1, this is 2, and when it tries to access index 3, there's nothing. And that's why it crashes and gives us this error, index out of range. So what we actually have to do when we're working with arrays like this and we want to basically use this count in a loop, we have to do this -1. And then that's going to go from 0 to 2, essentially. Now, it's really good that you know about the count property now of the array because that's really useful, but there's actually an even easier way to write this for loop. We can do something like this. For each item in my array, do something with it. And that's really the easiest that, the easiest that you can get. So you can do, if you need the index for some reason and you need to do something with it, you need to reassign something, then you'd have to use this method where you're accessing, where you're getting the index. But if you just want to, let's say, output each item, or you want to use each item without reassigning it into the array, then this sort of format is great. What it's going to do is it's basically going to loop through every single item in my array and put it into this variable for you to use. So let me comment this part out. Actually, let me just comment this whole thing out. And just a quick tip, if you want to comment out a whole block of code, you can press Command \, and that just takes care of that. So when we run our code here, so you can see this loop very simply is just printing out the items of the array. So this is a quick and easy way to loop through items in the array. All right, some other cool things I want to show you. How to declare an empty array. I think this is really important to know because right here we are initializing this variable to this array. But what really is the data type for this array if you were to explicitly write it? Well, I'll tell you, it is an array, so there's square brackets, and inside you put the data type of the array, so string. This array can only contain string objects. I forgot to mention that part, that your items in the array will be the same data type. If you wanted to declare an array that is empty to start, you could do something like this. Let's say empty array. So you could just have an empty array like that, but you have to declare the data type because there is no data type inside this empty array for Xcode to determine what data type that array should be. That's why we have to explicitly specify that right here. Or if you don't do this, you can do something like this. Let's do empty array2 is equal to, you could do that as well. So this is basically creating a new array object, right? This is a type. It's a string array. And you're basically creating a new object of that string array type, and it's not going to contain anything by default. All right, now let me show you some ways to work with arrays in terms of adding items and removing items. So you can, let's add items first. So you can do my array. There's methods like append, so you can append a new element, or you can even insert. So you can insert a new element at a particular index. And it's not going to overwrite it, it's just going to push everything back. So let's say I wanted to insert frog at index 0. Then if let's say I copy this down here and I print out the items again, you're going to see that it starts with frog this time, and then it goes dog, cat, bird. So it inserted frog at 0 and pushed everything else back. Now, another way you can add things, you can go plus equals just like that, and then you can add a number of items to the back of the array. So I can do frog, bear, and why don't we move this print statement down here, and let's see what is in our array at this point. So we have frog, dog, cat, bird, frog, and bear. Oh, and that's because I inserted frog at the beginning and then I appended frog and bear at the back. So that's our resulting array. All right, so let me just write it here in case you download the playground. That's another animal that I can use. There's so many animals out there. Raccoon. It's not like I saw a raccoon out there, but it just popped into my mind. All right, remove items. So my array, you can remove a particular item at a specific index like that. It's going to remove that item and everything's going to shift to fill its place. We can remove all, right? We can remove first and remove last. We can remove the first number of items. So there are a lot of options here. Like I said, these collection types are meant to make your life easier to manage collections of data, and that's why there are so many handy methods for you to use. Another thing that you might find yourself wanting to do is searching for a specific item in your array, or maybe finding out if an item exists in your array or not. Search your array. And the method to use for that is, there are a couple of options. There used to be one called index of, so you can, it returns the index of the item that you search for. If it doesn't exist in your array, it would return -1. Otherwise, it would return the actual index. But now there are methods like first index of, which returns the first index where the specified value appears, because theoretically, like we saw before, frog existed at index 0 and existed at index maybe 6 or something like that in our array. And then alternatively, there is also last index of. So you're searching from the back towards the front, and it's going to return the last index of that item which you're looking for. So those are a couple of handy ways for you to do some searching within your arrays. What I've covered in this lesson is enough for you to get the main benefits out of using arrays. As we continue to build apps together, we're going to learn new ways of using arrays, but for now, this is more than enough. Hi, and welcome to my Swift tutorial for beginners. In this video, we're going to go through another collection type called the dictionary. Now, these are really common, especially when you're working with data from a remote database or from a third-party API. All right, stay tuned. I'm looking at the Swift documentation here, and they give a really good example about the dictionary collection type. And before we go into the actual example, let's take a look at the differences between dictionaries and arrays, which we went over in the previous lesson, and talk a little bit about what makes them different and when you would use one over the other. So in the previous lesson, when we talked about arrays, I said that it's kind of essentially a list of your data with order 0 all the way down sequentially. Now, order matters, right? The data at index 0 is different from the data at index 1, 2, or 3. The dictionary, on the other hand, is unsorted. There is no order. Now, how do you put data into a dictionary? Well, data is put in as key value pairs. So each piece of data that you put into the dictionary, you have to give it an associated key to retrieve that piece of data later on. Think of it as kind of like, well, a dictionary where you have maybe the word being the key, right? When you're flipping through a dictionary, you're looking for the word. The value that you get from finding that word is the definition. So you can kind of think of it like that. Or in this case, the example that they give is that the value is the airport name, whereas the key is the airport code. Now, one very important thing that I need to stress is that the keys have to be unique, right? Or else it's not going to work. If you have two different pieces of data with the same key, how are you going to distinguish between the two when you look them up? Now, why don't we jump into the playground and let me show you an example of how to declare a dictionary and some of the ways that we can use it. All right, first let's declare a dictionary. So I'm going to say var my dictionary equals, and just like an array, you start with 2 square brackets like that. And then inside, you specify the data type of the key, followed by a colon, and then the data type of the actual value that you're trying to store. So in this case, I'm going to put string, colon, string, which means that my keys are going to be strings and my values are also going to be string. And just like you saw in the previous lesson about how to declare an empty array, you can do the same thing. I'm going to declare an empty dictionary just like this. So essentially, this is the type of the dictionary. All right, so let's go ahead and put some data into our dictionary. So we're going to type my dictionary, and then we're going to have 2 square brackets. In an index, you would put the index in here, right? Well, for the dictionary, instead you put the key in here. Now, our keys are strings, right? So I'm going to go ahead and put a new string key in here and then assign it the value that is going to be associated with that key. Now, the example that I want to use is cars and license plates, because license plates are unique as well. So why don't we just make one up? So let's say something like that. And let's say that this is a red Ferrari. And just like that, I've put in some data into my dictionary with this associated key. Now, how do we go ahead and retrieve that value? Well, let's try and print that out. First, you go my dictionary, and then you put in the square brackets and you pass in your key. So ours would be SJD293. So let's go ahead and print that. So you can see that it is a red Ferrari. But notice that it's wrapped in here in an optional type. The reason for that is because if you try and access, let's say, a key that doesn't exist, let me just make something up, let's just say 1, and there is no key in our dictionary with 1, as the key, when you run it, you actually get nil. So that's why what you get from this is an optional type. It could be a string or it could be nil. All right, so I'm going to write down some comments here. assigning data into a dictionary. This is declaring an empty string dictionary. This would be retrieving a value. As optional string. So typically when you try to retrieve the value for this key, you would assign it to something like that. Let's say my car is equal to this, and then you would have to check using one of those methods we talked in the optionals lesson, like checking it against nil, using equals, or using optional binding, or anything like that. Okay, so how about replacing the value for a key? So let's say we changed cars, but we kept the same license plate. Well, in order to change the data for that key, you would just assign it something different. So let's call it Black Lambo. All right. So just like that, we've replaced the value for that specific key. Now let's say that you've sold the car and you've kept the license plate. So here's how you remove a value for a key. Equals nil. Simply by assigning it nil like that, you're essentially removing the data for that key. And the last thing I want to show you is how to iterate or go through the items of the dictionary. And remember, there is no order, but we can still loop through the items of a dictionary by using the for loop. So it would be for something, right? For something. I don't want to write it right now. I just want to fill in the other part. For something in my dictionary. And then in here, do stuff for each item of the dictionary. Now, what is this something in here? Well, since dictionaries work in key value pairs, right? So we basically use something called a tuple. And a tuple, you can think of it as like a collection of variables. And what we're going to put in here is, let's say, key and value. So it's going to take each item out of the dictionary. It's going to put the key into this variable, and it's going to put the value into this variable. Right, so we can do something like this. Print key. Let's say, let's see what that does. We should put another car in here just to make things a little more interesting. Let's just use okay, let's try to print this now. So we get our two keys, but we only have one. That's because we removed this car for this key. Why don't we go ahead and comment that out? So we still have two cars in our dictionary. And why don't we run it now? So now you can see the two keys. We can also print out the value instead. You'll see our two cars here. Now we can use them separately. We can insert the key. Let's say is a value. You could do that. So that's how you iterate through a dictionary. So that pretty much wraps up using a dictionary, and you will find that it will come in handy alongside using arrays when it comes to organizing your data. So if you like this video, please hit the thumbs up button and please subscribe if you haven't already. Now click on over to the next lesson and we'll talk over there.